Hello, hello, and Happy New Year. Uh, Welcome to stream. Yep, I should also turn off the sound on my phone. Let me just get ready. Hope everybody is doing fine. And that your new year has started well. Hope that this year is going to be better than the last one. And yeah, okay. Let me just get ready, and I'll get back. I forgot to write down. Hello, Mighty Loopy. Happy New Year, yes. Just sorry for the delay. Uh, hmm. All right. All right. Sorry. Okay. Yeah. There is one more thing I forgot to do. Okay. Okay, that should work. Okay, so welcome. No, what is wrong with my voice? Need to do some throat clearing every time I start a stream. So yeah, again, welcome to the stream. Happy New Year, and I hope this 2024 is going to be better than the last year. I hope that I will personally publish more projects. You know, last year was. I should have actually done this stream as like a retrospective of what I did in 23, but yeah, maybe next time. I'm definitely planning to make a little blog post about my 2023. But yeah, it was mostly Shakedown. Shakedown from the start of the year to August, when I published a Finland, which you can see here in the screenshot. Although I didn't publish the car, I did publish the track. And then after that, I started working. Yeah, there was the Unity stuff happening, and then I decided to try Godot. And then in Godot, I was working on I was trying to make the space station game. And I thought it's going to take me like 2 weeks. And it turned out that it took me from like end of September to the mid-December, basically, when I was just so annoyed by Godot that I just quit it. And then I was just thinking about what is the minimal way to make something with it and then publish it as like some kind of a demo thing. And then maybe move that game into Unity. And yeah, in the meantime, I was a little bit depressed. I had some other stuff going on in my life. Yeah, it was kind of a difficult time just before the new year, maybe like 2 weeks before. I didn't really work much. I was more like I was opening a lot of old projects and just being overwhelmed by how much work I've done in some other projects, and then I've never done anything with it, right? And then I was just thinking about like, okay, what do I do with these projects? What do I finish them? And then I was making some plans, and still making plans for this year. I really want to dedicate myself to some plans and not just randomly decide to make a game, this year, and then just go on forever making this game and never finishing it. Just like I did with the space station game. It was more like the space station game combined with the struggling in Godot and then with other stuff in life that has caused me to reevaluate everything. Okay, so yeah, my decision for the beginning is to go back to Shakedown a bit. There is a lot of things that I need to do in Shakedown that I imagine would make it a lot better game. So yeah, let me actually just open these. Let me just show you what's going on. Okay, so this is the 96th stream of Shakedown. Because yeah, I am going back to Shakedown kind of. So this is again the Shakedown, but really this is more like a standalone thing, a standalone stream, which is just going to be a little bit of like going back to C++. I'm not even going to work in the Shakedown Rally project, or this is a separate thing. This is a sort of a little project where I experiment. Oh yeah, this does not exist. This is a little project where I'm experimenting on different like containers in C++. And so I kind of want to make a ring buffer, which is something that I wanted to do for a long time, but I just never, I never actually really needed it, so I was always postponing. And yeah, I do want to kind of work on that. So on this stream, this is just going to be about implementing a ring buffers, which is kind of unconnected to the Shakedown Rally the game, but it is connected to the engine. So it's something that's going to be, yeah. And let me talk later, slightly later. Is that even a sentence? A bit later about what a ring buffer is and what I want to do. But first off, yeah, looking at the to-do for Shakedown, right? So keep in mind that the last time I actually worked on Shakedown was in September, if I remember correctly. And at the beginning of September or something like that, right? And I have done, this is the to-do of everything. So yeah, hello Drainyard, Happy New Year. Yes, Happy New Year to you too as well. Hope that this year is going to be better than the last one. And yeah, I haven't done Shakedown Rally development for like, 5 months, something like that. 4 months, September, October, November, December. Yeah, 4 months. 4 months, you could say. And this is all, yeah, this is my giant to-do things, right? Where I just put stuff. Some of these are random, some of these are like important things to do. And yeah, let's look at a stream. So this is the new stream. I did add a little note, which I'm going to talk about later. But yeah, my last stream that I did at Shakedown, it was 95th stream, approaching 100, which was about disappearing particles. Oh yes, what I did is I added a tetro, which is this car, the car that I used in Finland. Yeah. Refactor audio to load different car sounds. Yeah, I even forgot that I did this. So basically I made a audio loader. I totally forgot it. I have to say I totally forgot it. Let me actually launch Fork, which is, a Git client that I use. Yeah, and then before that I added some grass. Why did I not make this done? I definitely added grass. Color correcting, gravel physics. Oh yeah, I think I remember that I skipped a few. I decided not to stream a few things, which is because it was like before release. I really wanted to release this Finland update. And so I didn't actually... I didn't do a lot of Finland streams. Upload new builds. In Finland asset track splitting. Oh yeah, this was the big rework where I published this is where I kind of split the demo from the paid game, and then I put the price for it. And by the way, if you bought Shakedown Rally and you had this payment issue with PayPal, I'm really, really sorry, because in the past few weeks I was really slow answering. And I still have a few activations to send, I think. But yeah, I have to do this manually, and because itch has this problem between direct payments and itch confirming that you actually bought the game, which is really annoying. So I kind of have to just send keys to everybody individually. But yeah, my big plan for this month, by the way, is to put Shakedown on Steam. So yeah, that's the big news for January. Well, until the end of January, I hope I will have it. And then hopefully there's gonna be less problems with, with payment and stuff. Okay, so let's see. What did I do? Yeah. This was all about splitting the maps. So now you can load different maps and load different cars. Talking of, by the way, there's a new thing that popped up in the meantime, just before New Year. Somebody, well, I'm not gonna say somebody because I'm gonna look into who actually made it. I think they posted into the mods. Oh, I didn't even see this. That somebody wrote down. Oh, look at this. Nearly all mods for Shakedown so far. These may not work. All credit goes to creators. Oh, nice. So somebody made... So somebody just rewrote everything because... Nice. Oh, that's actually cool. Kudos to Weiss. That's cool. Yeah, so basically what happened here, as far as I understand, is that because I changed how things work, right? I split the cars from the main config. Before, I had one config which contained all the parameters for tracks, for cars, and then I split them. I split them into different files. And so the old mods don't work anymore in the new versions, right? So this guy actually separated the configs himself or herself. In speed, and that excuses Polonaise, but all of them basically have changed wheelbases from the original. Nice. Okay, so he or her figured it out. Nice. I didn't even know that. Okay, let's try. I want to see the WRC car. I never actually tried it. I don't think I tried the WRC car. Okay. But yeah, anyway, after I didn't want to talk about this, but this is a good surprise. What I actually wanted to talk about is this thing that Stefan Mielke made, and that's a tool to change the maps and cars while it's not implemented the game. In the game, yeah. So a big plan for Shakedown, by the way, is to actually implement, changing cars and tracks in game, and it's somewhere here probably. Cars and tracks separation, in-game menu for selecting cars and tracks. Yeah, I guess that is it, but although it's not just the menu, it's the whole thing that I need to reload, because right now the way it works, the way the game works, is that I just load everything and start, and I don't think about and so if I want to create, like, basically I load the car models, I load the track models, I build all the physics, right, for them, like the colliders and stuff. And if you want, and then it basically persists until the end of the game, right? I don't change the memory or anything. They're always static. I don't even add more objects. I don't remove objects. There's nothing. And if I want to create selecting cars and tracks in game, I would have to make I have to remake, I have to refactor almost the whole game, right? I mean the loading part, right? But it's a huge chunk of the game. It's to support that, like, oh, you can actually remove cars and then load new cars, and remove tracks, load new tracks, right? So yeah, it's a big job, but it is definitely my plan to do this. Meanwhile, Stefan here, or Stefan, I don't know if it's like a German Stefan, then yeah, he made this little tool, which is this loader. And it's actually pretty cool. You can download it. You can download the release here with the releases. The only thing you need is you need the runtime. What is it? Yeah, it is this Net Desktop Runtime 8, which I didn't actually have, so I had to go to the Microsoft site and download it. And then what you get is you get this. So if you double click, you get a little selector of like, okay, pick your car and pick your map, right? And then what you do is, do I actually have to save, or do I just select like this? I'm not sure. Of course, you point to your installation, and this is my like test thing where I can, you know, load these things. And yeah, let's see if this is actually going to work. Oh no, it is actually using the previous. So yeah, you do actually have to you do actually have to save the config, right? You have to click save config and then launch the game. It would be nice if it was automatic or something. Okay. Or maybe it says like, oh, you didn't change the config. And there it is. I have a different map. You know, I can drive it around. And this is actually a tarmac setup. This is not the gravel setup. But yeah, if you go to the... Oh, by the way, I should put my audio out a little bit less. Oh, and by the way, my cable has fell out. Doesn't matter. Yeah, let's try the gravel car on the Finland. Yeah, this is the correct one with the correct suspension distance and stuff. And there it is. I can slide now. Cool. Okay. Yeah, and what I can do now is I can just go, okay, I want to go to Monty. Let's... Oh, I forgot to save config. Yes. Okay. But yeah, it does work. It does work. You have to say, oh, hello. It's hello, Stefan or Stefan. There we go. Yeah. Yeah, you have to save. I realized that. It would be nice to be able maybe there's like a yes and no, like, oh, are you sure, do you want to start with a new, you know, do you want to override or something? I don't know, something like that. But that's cool. That's cool. And there you go. You can now drive different cars without having to run. The way I implemented in my game is, of course, I had okay, let's load it. Let's go here. Yeah, the way I implemented it, I have this bat, you know, which basically just loads a different config, and that's how I do it. Yeah, so if you want to drive Finland, you just start the Finland bat. Okay, well, that is right now how it works. And here's a little helicopter shot. Okay, anyway. Yeah, let me actually try the WRC car as I did. Okay, so let's see. Because WRC. Oh, it does actually override spec car. Okay, interesting. But what if I don't want to override this thing? Okay, this is a bit... Maybe it could have been called something different. Okay, let's try this. Okay, so this is the WRC car, right? Let's call it the WRC. Okay, and then I'm just gonna rename this to WRC. And I don't know if it actually has other options or not, or if they work. So just try to do it like this. And yeah, let's have a... Oh, what if I keep this? Does it point... You know, I even forgot how it works. Yeah, it does actually take the model in the local folder. Okay, let's see. Let's see what it says now. Load assets. There it is. We have some different cars. Okay, let's try it. Save. Let's not forget to save. Okay, there it is. Looking cool. Nice. I could even... Oh, wait. I feel like the wheels are slightly... Yeah, it should be slightly bigger, maybe. So this looks cool. Oh, it even has... Oh, nice outline. This is strange. This is like a polygon. Polygonal overlay. Look. But that's pretty cool. Do the headlights work? Oh wow, yeah, they do. Nice. Pretty cool. Okay. Yeah, there you go. You can now have different cars, and if you look at those mods, you can also download. Okay, let me actually try the gravel one in Finland. By the way, Azello here says, I'm curious, how did you do a road for your rally game? Do you have some custom tool for that, or is the Blender was always curious how people do that outside Unity engines? Yes, I basically use Blender, and I use a lot of geometry nodes. So these roads, yeah, look at that. That's pretty cool. Yeah, these roads are mostly made by... Oh, and even the... Wow, the bumper... the bonnet cam, the hood cam is pretty cool. Oh, I got stuck in a tree. Yeah, it is... I use a lot of geometry nodes here to, like, make a road that goes along the spline. And, yeah. But you can also watch my previous streams if you go to my YouTube channel, the same name. Just look for me on YouTube, Notke, and you will find some old streams where I'm making the tracks. So yeah, take a look at that, and let's try to drive one professionally. No, don't fall. Good, okay. I didn't shift down. Yeah, I do need to improve shifting it down and up. Definitely. Because it doesn't shift down always. Sometimes it gets stuck in a higher gear. And, you know, it gets... This is where... You need to jump sideways, by the way. Oh, fuck. I fucked myself up. If you jump sideways correctly, you will then slide right into the straight, as we see here. And then you do a little bit of a slide here, and then do a little bit of braking. Yeah, that was too much braking. I have to fix those seams on the sides there. I am driving on the keyboard, by the way. There's a trick here to jump across, but I'm not doing any of the tricks. And here as well. The grass makes you really, really slow. I also have to improve the physics of the grass, because right now it's just slowing you down. Thank you, tree. Oh, fuck. Wrong turn. There we go. 164, not bad, but I can do better. Okay, so yeah, pretty cool. Let's see the replay. The car is a little bit too dark. Like the blacks of the car are a little bit too black, I feel, and they get washed out by the compression. Yeah, well, for you it's probably compressed. It's probably compressed. Oh, free look. Yes, let's look at the car passing by on this stretch. There we go. It's coming. It's coming over. Whoa, cool. I can fly a bit. Oh, that was a nice slide. Wait. Is this an old version of Shakedown? This is 2595 build. I have a feeling like it has the old issue with particles. Oh, this is what happened here. Let's see what happened. What did I do here? How did I dig myself in? There was some kind of a physics thing. There it is. Yeah, I don't know. I dug myself in somehow. No, not the speed. This thing. Okay. Somehow. Ah, yeah. It's basically bumped. The body bumped into the ground, and that's why I got redirected, which doesn't happen on my on the other car. Oh my God! More. I just noticed. It says. Okay. Cool. Okay. Let's see here. From the vantage point. Here we go. Nice turn. Not bad. Not bad. Okay. Anyway. Yeah. So that's the Shakedown loader, folks. It's pretty nice. Thank you. Thank you, Stefan, for that little thing. while I'm implementing the in-game. Yes. Anyway, should I try something else? Let me see. Oh, I didn't even try this one. C-class. Is it using a different... I wonder if it is using a different... Oh, it's still... Why is it... He didn't rename any of the cars. He should have. It is slightly annoying. So if you go into here, how is this loader gonna load these? Oh, just like an extra spec 17. Yeah, let's not do this. Let's do a something. Let's call it C class. I don't know, maybe it was just easier for him not to rename anything. And I don't know if these are like... Yeah, anyway. Let's see. Yeah, there is the C. Should I try it? Should I try the gravel one? Oh, wow. That's a pretty cool one. That's a pretty good looking one. And it's actually gravel. Gravel car. Wow. That looks cool. I have to say. Really well done. That pixel art is amazing. Is this like a real photo? Or I wonder, or was it? Oh my god, even the sign. Look at that. Look at the little sign. It's beautiful. Cool. Cool stuff people make. Yeah, it is a bit funny that it's like a WRC engine sound. There is still a problem with the particles, but man, look at those. Oh no, it doesn't light up. The headlights don't work though. Ah, too bad. But my god, the wheels also look perfect. That's beautiful. Beautiful stuff. That's crazy. Okay. Anyway, let's try the let's try it on Monty. Yeah, it's a tarmac setup. Oh, there's so much stutter while I'm streaming, but that's just... Yeah, it actually does feel like the normal rally car. So, yeah, too bad. Too bad it just feels like a... Yeah, I need to drive it like this because there's too much stutter. Too bad it drives like an... Wait a minute, it does have headlights. It does have back lights. But it doesn't have the front lights. Yeah, it doesn't have... I mean, the light works, right? But the headlights are not the headlight textures. Oh yeah, of course. There's no handbrake, but I can just make a point turn. This looks very appropriate, you know, like a restaurant and a Merc. In the restaurant, I don't know. Boom, there we go. Oh, look at that! It has... what is this? It's like reverse... It's like reverse mesh. I have to ask whoever made the mod, you know, to improve it or something. But yeah, I should definitely, like, yeah, it shouldn't be so easy to turn, right? It should have a lot weaker steering, for example. Yeah, oh, this is maybe too much. And definitely less, you know, acceleration. Maybe less spring as well, or maybe less damping. I don't know. Let's try something like that. Yeah, this is too much. Too much. Too weak. But yeah, also less friction, I think. Maybe something like this. Yeah, it is a little bit too jumpy. It should be softer. It should definitely... I think that the... Oh, less roll bar as well, for sure. So it slides. So it leans. But there should be more damping, but less spring. So it's like super soft. Yeah. Something like this, perhaps. Yeah, this feels heavier now. Nice. Man, those highlights are beautiful. It really feels like the graphics are much better than they are, right? But this is just flat color, right? There's no lighting at all, except for the shadow, the fake shadow that they have, the vertex shadow. But these highlights are just painted in, you know, and they look amazing. Okay. Getting stuck. Feels like an old version of Shakedown. I don't know why. Because I'm getting stuck all the time. Too much break in time. That was a good one. That was conservative. Okay, let's be conservative again. That was not conservative at all. Are you kidding me? That was the worst. That was the worst crash ever. That was the worst crash ever. What happened there? What happened there? Huh? Look at that. Damn physics. That's terrible. Just stuck inside a polygon. Boom. I don't know, it crashed with something, with the polygon there. Maybe there's something wrong. Maybe I don't know. Is the hull, collision hull too complex or something? I don't think so. You know what? I'm actually surprised these wheels look so good at speed. They almost look like they're blurring, but they're not blurring. It's super interesting. Yeah, that was a crash as well. A polygon hit. Anyway, that's a pretty cool car. Anyway. Yeah, now I can try. Oh, look at that. Look at that view. Amazing. And the suspension working. Beautiful. Okay, anyway. Anyway, enough of that. I just wanted to say that Shakedown Rally Loader is pretty cool. You can load different cars. And there you can try different cars, although they're all called Spec 17. So, yeah. Yep, they are like, oh, Ford Focus. I didn't even know this one. Wait a minute. I have to try this. Okay, before I go on to making the the ring buffer. I'm sorry, but I have to try this because I haven't seen this one. I haven't seen this mod. Okay, well, I guess again I'm gonna need to rename some of this. Let's call it F. Okay, and let's load. Wow, so many cars now. Okay, let's try this. Whoa! Oh, this Focus. Okay, yes. Oh, and I think... Oh, this is a low poly car. Yeah, it is. Nice. This is the newest one, I think. But yeah, definitely needs work on the texturing. But also the wheels are too... Wait, let me resize the wheels. When you press F1, you can see the wheel debug, by the way. I think I can actually resize the wheels here. There should be a wheel radius somewhere. Maybe I don't have it. Tire outputs. Main multipliers, geometry, raycast, ride height. I don't have a wheel. Okay, this is the maximum height. The ride height, okay. Interesting. I do not actually have... I do not have the radius of the wheel, unfortunately. Yeah. Okay. Maybe that's a thing to add. To add into the game. Okay. Anyway. That's cool. Oh, it doesn't even have the brake lights. But yeah. This seems like... this car seems to be like a work in progress thing, right? And it has a French and a Finnish flag. Interesting. Interesting choice. Oh, and now I also see the antennas, which maybe, you know, maybe I could make them like move a bit in a physicsy way in the game or something. Oh, there is actually a steering wheel, except that it's completely black, so I don't see it. But yeah, that's pretty cool. Okay, anyway. Damn, is this your game? Yes, it is my game. Yes. And somebody made a... Stefan here made a loader. And some of the mods. So yeah. And I don't have any other... Yeah, the last thing I actually did was make a tetro. Let me find it. I had somewhere in the tetro... Oops, whoa! Tetro, okay, there it is. So yeah, I should be able to just copy this. Put it in the cars. Copy it. Load it. Reload assets. There it is. Oh, and I think it only works on the gravel. So let's check it out. Yep, there it is. This is like the Group B car that I had in Infinland. Oh yeah, and it has ridiculously high like sound pitch, you know, but it is slightly more powerful than the WRC car in the top, but it also the brakes are much weaker, the sliding is much worse, and yeah, basically a Group B car, you know. Why does it start so slowly? Oh, it needs to spool up probably. That's why. Sounds like a Formula 1 car with this high pitch. Almost rolled. It has a higher top speed than the WRC car, I think. Okay, anyway, there we go. It ends in the in the forest. So yeah, there's the game, and that's also the car that that was the last thing I did for my stream back in August, right? The 95th stream I added Tetro, and I tried to add different audios, I guess, but I don't actually hear it. So I'm not sure what's going on there. Anyway, add grass and small foliage. Yeah. So in this gigantic to-do, as I said, I have all the stuff that I need to finish. By the way, what did I put for Finland? I don't have a Finland to do. I don't even have it. Yeah, because I did kind of finish it. But yeah, anyway, handle GLB cars. Handbrake, of course, killing the engine, capsule colliders to trees, and stuff. Oh, I shouldn't actually, maybe I don't need to add the capsule colliders to trees. Maybe I should just, yeah, do the same thing as I did in Finland, which is just create some proxy mesh colliders. Or proxy mesh colliders. Yeah, but as you can see, so many to do. Exhaust booms. Yes, I definitely need that. Remove tree. Oh, from object and material text. By the way, this made all the streets uncollidable. Because, so here's how this thing works, right? If I want something to not have a collider, I say, okay, if the name of the object contains tree, don't make a collider, because it's a tree, it's a forest. I don't want to collide with the entire forest. And the problem is that the word street contains the word a tree, so streets were actually uncollidable. And yeah, I had this problem that when I had to rename all the streets to roads, and I didn't know at the time, like, what the hell is going on? I think I've, why until I found this thing, which is like, oh shit, I'm actually checking for the word tree, which is also in street. Yeah, ridiculous. But I think I actually fixed this. Let me see what was the last thing I did in Shakedown. Added height fog. To what? Oh, to common? Interesting. I don't remember that I did that. Fog shader. I was doing some fog shader. Big grid with... Oh, this is actually the grid. Yeah, I was actually working on a grid... how to say, the quad tree implementation. Yes, this is it. So this is not actually connected to to Shakedown. Yeah, it was this Tetro torque curve. Yeah, that is what I was working on. Tetro after the release. This is the last release I did. V22 checkpoint scale report. Yeah, GUI. I did a little bit of cleanup. Splash GUI. Oh yeah, I remember I was fixing this splash from the ImGUI and stuff. Yeah, but as you can see, still so many things to do. Yeah, so many things to do, and I should actually tidy this up a bit. Oh, I do have nighttime, which I kind of implemented, but I didn't actually. You don't have a proper nighttime. It's just the ambient color is different. um, helicopter sounds, reverbs in tunnels, and stuff like that. Yeah. So a lot of things to do for Shakedown. And yeah, this archive is just all the stuff that I've already done, which is a lot, you know. But anyway, today, well, the main thing that, yeah, enough of showing what I did, all my past glories after 1 hour of streaming. Has Godot pissed you off enough to dump it? Kind of. I do want to finish the space station game, but not like finish, more like do the minimum amount possible and then just publish it as like a little demo or something. Yeah, something like that, and then yeah, and then I just don't want to see Godot again. I'm thinking about moving the space station game to Unity, and yeah, pretty much. So yeah, but it did piss me off. It did piss me off a lot. And I don't really want to continue working in it until I, actually a few days ago I saw that Juan was talking about reworking the asset import system and everything, which is pretty cool. But until they do, I think I'm gonna not use Godot for now. But Godot, that's not the only issue, of course. Godot has so many issues that I wrote about, and I made a list. You can find it in my gist. Anyway, let's move on and go back to my C++. So, I showed you the Shakedown loader by Stefan Milke, I think. Yes. Nice. Thank you. Okay, on this stream, I'm gonna implement a ring buffer. And okay, let's first talk what is a ring buffer and why is it interesting. So what is a ring buffer? Okay, first we're gonna do that, and then we're gonna make a ring buffer class, right, in C++. And yeah, I don't know, what are we going to do? Yeah, I should also I don't know, what are the steps for making the ring buffer? Yeah, let's think about it later. So, what is my purpose here, by the way? So, this project here is called Not Collections, and you can find it actually online if you look for Not Collections, there it is. Simple high performance collections. That's actually completely open source. It's on my, I did not put a license though, but yeah, it should have like a MIT license. Yeah, what this is that it's a bunch of a little bit of templated collections that I made, and I'm actually using this in my engine. So the two that I'm actually using are the walking pool. Wait, is there more branches? No, there's only one. Okay, because I thought I have more. I have a walking pool, and I have a swapping pool. And what are these? Well, basically, a walking pool is like a container that holds some data. So it's like a vector. It does actually, it does have a vector of bools, but it keeps track of which items are alive and which are dead. So you can, it's basically a classic pool, right? It's you can store some items, and they can be dead or alive. And if they're dead, basically if they're dead, I skip them when I loop through them and stuff, right? So they don't have, I have this iterator, and basically the iterator checks Wait a minute. Does it actually check? Maybe it doesn't. It doesn't even check if it's alive. Interesting. So I don't actually skip. The iterator just goes from the start to the end. Cool. Yeah, and is there is alive? No, there's no is alive. Okay, I even forgot that I'm doing this. I guess I'm doing this manually. So this one, for example, is what I'm using for game objects, right? So they can be dead or alive, right? And I mean, they can be removed. But what's the point of the walking pool? The main benefit of this kind of a pool, which keeps track of what is alive and what is dead, is that the objects don't change position in memory. So they always keep the same position. And when something dies, I don't actually remove them, right? It's not like a vector. Like in a vector of, classic vector, I don't keep... you erase when you erase one item, right? Let me actually go back to here, right? If you have an array, you have some items, right? You have some items. And what happens is if you have like one... Okay, I am going to need this later anyway, so let's do something like this, okay? Can I just select things, please? Okay, I'm gonna delete this one. 1, 2. Can I enter? Yeah, 2. Okay, there should be no enter. 3. Doesn't allow me to confirm. 4, 5, and so on. Right? Yeah, let's do this. Okay. So in a classic vector, you have some things. Let's say I want to delete 3, right? I delete 3, and what happens then is the 4 and 5 will move down like this, right? And the problem with this is that if I had some kind of a pointer pointing into this item, this item is now 5. This is not the 4 anymore, right? I had, because the pointers don't preserve, what the hell is this? Their locations, right, in a classic vector. And so, I wanted to point into 4, but now I point into 5. And the more dangerously is if you have a thing here, and you're pointing into the 5, and you move down, and now it's pointing into nothing, right? It's pointing into like a unused memory, or, well, okay, in this case, maybe it's gonna work, right? Maybe there's not gonna be an error trying to access if you grab a pointer to this. But if it was at the end of the line, that would be really bad. Oh, wait. Well, if it preserves capacity, it wouldn't be. Yeah, anyway. But the thing is that you have this, right? You don't have this thing. But in my case, in the walking pool, what I do is when I remove an item, I keep this dead, right? So it's like, okay, this thing is dead, right? So I just say, okay, this thing is nothing, right? It's nothing. So if I can still point into these things, and that's going to be safe. And if I add a 6th one, right? If I add a 6, instead of putting it at the end of the queue, what I actually do is I put it in here instead of the dead one. And so you might also ask, what if you now point into the wrong one? What if I wanted to point it through? Well, that's up to you. That's your problem. But my thing is that with a walking pool, I solved this problem of like, while things are alive, they're not going to change positions. If you still point into the dead object, that's a different story, right? That's your problem. And then another thing that I have here, that's the walking pool, right? And I actually did a very simple implementation of, I have a few things. I have the data, I have the size, I have the vector of bools. And basically, what I do here is I malloc the space. And the reason why I malloc is that I want to avoid constructing these objects. That's why, right? Because if you do it in C++, it's going to just construct all the objects. And yeah, but I just want to malloc the size and then fill it up with my own data if I want. And yeah, and then basically this is what I do. And finally I have this iterator. The reason why I have the iterator is because you can then do a range for through it, right? Like this, right? You have a for auto something through a vector. In this case, I was testing a fixed vector, which is something different. But anyway, and the other one that I use a lot is the walking pool. Sorry, that was the walking pool I was showing you. The swapping pool. The swapping pool is similar to the walking pool, but the objects do change position. So if I have this 3, right, what is happening if I remove number 3, what happens is that number 5 is, so as I said in the classic vector, what happens is that if you erase, you're going to have this thing happening, right? But in the swapping pool, what I do is I simply replace the third element with a 5, and that's how I solve. Basically, you can have a huge array, right? Thousands of objects, or maybe even millions, I don't know. And you only have a single operation to swap with the last one. But the problem, of course, in this case is that now this is no longer 5. The 5 is over here. So whatever pointer you have that points into the objects, it needs to change. It needs to change. And it needs to be notified by the removal. But that's not so much important. But yeah, more interesting is the actual swapping that's going on. Okay, but both of these are very actually similar to vectors, and technically I could have implemented both of those with vectors and just swapped the elements myself. But it's just kind of nice to have a little interface. And also it was kind of like a practice for me to implement it myself. And much simpler than anything that if you look into like STL, right, the template library, the standard template library, it's completely unreadable. It's you look at it and you're like, what the hell is going on here? And I just wanted to implement something that is simple and I can look at it and I can reason about it, and I'm like, this makes sense, right? But then so this is more like a C style of implementing collections, right? More than a C++ style. The problem here is though that in C++ you have constructors and you have destructors, and you have to if you have some kind of a complex object that has complex types within it as members, right? Then it's important to handle them with constructors and destructors, and here I'm kind of I'm kind of handling it as a template parameter where like, okay, you should put like, do you want items to be destroyed or not? And it is a little bit ugly, I just do a if const expr, do I have no destruct or not? And then if yes, then destroy when I release the object and stuff. But yeah, that is how I sort of like circumvent the C++ things by manually destroying, firing the destructors when trying to remove objects and stuff. Shake on my down till I not get, yeah. Cool. Hello, Casper. Good morning, Happy New Year. Yeah. Not morning over here, but good morning to you. Yeah, so yes, I want to also implement a ring buffer. And what is a ring buffer? Well, let's go back to my little array and with my nice numbers that are popping out. So let's say that, yeah, basically what is, yeah, if you want to implement some kind of a structure that is like a queue, where you can put in numbers 1, 2, oh, I actually moved this around. Let's actually get this back. 1, 2, 3, 4, 5, right? And you say like, okay, I want to put stuff in. And oh yeah, for example, a stack, right? What is a stack? A stack is like you push things in sequentially, and then when you pop things out, you pop them in the order they were, like in the reverse order, right? So you would get 5, 4, 3, 2, 1, and so on. And there's another structure which is the queue. The queue is basically like, okay, you have 1, 2, 3, 4, 5, and then you take the first one out. So it's like going into, going into a shop and you're at the cash register, and it's literally like a queue, right? Where whoever came first gets served first, right? But there's a queue. So you pop the first, you pop from the front, right? So that is very useful when implementing stuff like, okay, I just want to send something, maybe asynchronously as well, because that's where queues are used a lot in asynchronous code. Like, oh, I just have a queue of operations that I want to do, and I schedule them, in a queue, and then I execute one by one. But here's the thing. There's actually a way to implement both the stack and a queue at the same time, right? Because why not? Why wouldn't you? Yeah, one of the things with us, I actually don't know how C# implements the queue. Does it actually move all the elements? I doubt that it actually moves all the elements. It probably implements it as some kind of a reverse stack. I'm not actually sure. But anyway, yeah, the way you can do this. So, by the way, yeah, when you have a stack, right, you have something which is like well, what did I do here? Oh, what is going on? Wait. Okay. So you could have something like a pointer that points to the first element, right? You can say, okay, if you don't have, let's say that I'm also picking up everything else, right? Let's say that let's say that this is empty, right? It's an empty queue, right? A stack. Okay, let's go with the stack analogy first. And for example, this thing is a pointer that points to the last element, and you say, or maybe it's like the count, right? It's like, okay, this is 0, right? This is position 0, and we have to, when we push an item in, what happens is that we put at the where this pointer is, and then we move it forward. So this is also called the head. So I'm gonna say the head from now on. The head moves forward, and you know where you are, right? And yeah, I mean, you can also make the head, oh, why is this curving? You can also make the head be at the position of the last element or after. I actually prefer having a head that is after the element, because it's like, okay, you push in an element and then you increment the head, right? And so as you're pushing stuff in, you're moving this kind of a pointer ahead, and when you actually reach let's say I want to pop from the stack, I move it back, right? And then I say, okay, pop this one, and then I have this one, and I can pop another item, something else, and then move the head forward. But here's the thing: in a queue, you have a pointer that is at the beginning, kind of, right? Well, it's always going to be at the 0 if we're actually moving the items. I don't actually know how the queue is implemented. But anyway, here's the thing. What if what if not only we could pop things from the front, but what if we could also, pop things from the back. What if we could also pop things from the front, right? But preserving the, we don't have to move them back, items, but simply, okay, this is now out, right? We have a thing outside. We popped it from the front, and we can still pop from the back as well. Well, this is kind of the early form of the ring buffer. And yeah, you can say that it's kind of like a double-ended stack. That's how you could, it's like both a stack and a queue at the same time. And how it works is actually by introducing another pointer, which is going to point into the beginning, right? So if we don't pop from the front, it's always going to be at the 0, right? It's always going to be at the 0. So it's basically, it's keeping track, this kind of a structure is keeping track of where's the beginning and where's the end. That's basically it. Oh, is this going to crash? Is Firefox going to crash? Let's see. And now why is it called the ring? Because, why is it not just the double-ended or like queue queue stack or stack queue or something? Well, here is another killer feature of a ring buffer, right? Yeah, if you're popping from the front, you do this. Okay, and let's say that I'm adding stuff to the end. Yeah, let's just add numbers because I don't have enough numbers. And I'm putting these, I'm popping some from here, okay, maybe doing something else. And let's put them in here. And I'm also offsetting to here. Okay, I pop a two, let's pop few more. Let's pop 2 more, okay. And let's add these at the end, right? So what happens here, right? What happens when the ring buffer overflows? When this thing happens, right? I just say, well, you can't use this buffer anymore because you're out of space. Well, here is what you can do. You can just wrap it around, and you can say, okay, the head now is over here, and you can push an item on the beginning, and you've essentially created like an infinite thing that moves around, right? Now if I pop more things, right, and I push it back into the push at the back side, I just continue doing this, right? So yeah, this is how you basically create some kind of infinite moving data structure that is, yeah, but the cool thing about the buffer, the ring buffer, is that first it will always keep the same size and it has a limited size. So what happens if you fill it up? Okay, let's actually make a smaller one because this is it is annoying to go all the way to the end. For my display, I can just have 4 elements. I don't need all these elements. Okay, and let's actually make them white. Okay. Yeah, so we have, by the way, if both of these match, right? If both pointers match, they're you could say that it's empty, right? This is also why well, actually there is a little caveat here with 2 matching pointers, and I'm gonna shortly mention it. Okay, so yes, if you push a thing, right, you move the head, and by the way, this one is the head. I can't remember if I used I think it was, I actually used the red one for the head, right? 5 minutes ago. And this one is actually usually called the tail, but I actually previously used it, called it the foot. it makes more sense to me that it's a foot and a head. But then I was Googling ring buffers, and I found it that they actually call it the first pointer, they call it the tail. So I'm gonna go with the tail because that's more of an industry standard. So yeah, if we push another item, let's push in the number 2. Yeah, we have this thing, and then we push another one. Let's push in 3. So this is just like a 4-sized ring buffer, right? We don't need any more. And you know, we have a 1, 2, 3, 4. And what happens if we add 5? Well, we either can issue a warning and say, whoops, error, it's full, or we can simply override it. You know, we can just say, oh, hey, it's actually, you know, now the new value is 5. It's not 1 anymore. And this is actually a cool feature that you can have. So yeah, if we do this now, oh, by the way, we had 4, so it was over here. And what happens here is we move the head to here, but it's actually, that's the filled one, which means that we have to move the head over here. Yeah, this is the weird situation, because what's the difference between this? Wait, let me actually remove this one because I don't need it. What's the difference between this one and this one? Sorry, this one. Right? They're both kind of valid. They have a head in front. They have a foot. Oh, of course, the foot needs to move. I wasn't thinking about that. Of course, when you fill up, when you wrap things around, you have to move the foot as well. Yeah, that makes sense. Okay, so what is the difference then between the empty one with both pointers at 0, and this one where both pointers are at 0? Well, the only difference is the size. You know, I should definitely track the size of it as well, like the number of entries, so that I know that there's a difference between an empty and a full one. Yeah, I should definitely add those little methods. Okay, well, I did actually show how the ring buffer works, but why is it even useful? I forgot to say this. Well, one of the ways to use a ring buffer, for example, is for does the Windows still have the trail effect? I wonder. Does it still have the trail? Oh, am I giving out some sensitive data? Maybe. Let's look for it. Trails. Trail. No result for trail. No, nothing. I don't know. Is it maybe personalize trail? No, nothing. Maybe that just sucks. Mouse. Okay, let's look for a. You know, there was this trail thing. The mouse options. Is there mouse options? Change how the mouse pointer looks. Okay, let's see. Pointer options. Yes, there it is. Okay, let's go back. I'm not giving out sensitive information anymore, except for my beautiful background. But yeah, of course, you can have a trails. There it is. Look at that. Look at that. Oh, classic. Such a classic, Windows 95 feature. I'm glad it's still in. Well, the trails are basically implemented as a ring buffer, because the way you do it is you have a position, right? You save positions, you push positions of each of the mouse sequentially, right? You're like, okay, current position, current position, current position. They're all current positions, and then you can render each of them. But what happens is that once you fill up this buffer, right, you simply override the last one. The final, how many of them? There's like 10 of them or something. No, there's less than 10. I don't know. It's a slope fast. Let's do it very. Oh, no. I didn't want to to change the speed of the pointer. I wanted to. Okay. That was the longest one. This is the shortest one. Yeah. If you make it super long, then you can see how many of them. There's like 7 of them, 8 of them, or something. I would need to take a screenshot to really see. It doesn't seem like 10, and it doesn't seem like 5 either. So anyway, yeah. So this is basically how you would implement a trail in a game as well. One thing you can do as well is, for example, for Shakedown, this is how I can implement a tread marks. On the pavement, you have these points that connect, and then you generate a mesh from it. And as you fill it up, right, you can have like 1,000 points, and then you create, as you fill it up. I don't want to like infinitely increase the number of trails of thread marks, right? What I actually want to do is at some point they should start disappearing, right? And you can make them disappear by, just overriding the last position and, basically a ring buffer. Another thing is, for example, footsteps. Like you can see footstep marks, which is basically the same thing, right? Over time, they will, they will disappear, and it could be like a first-person game where you're leaving foot marks on the pavement, and then they disappear over time, and you replace with it. Yeah. So that is why ring buffers are very useful, right? You can have that as well. I could actually even use it in a replay. If you have a super long replay, maybe I can just implement it with a ring buffer. So it's like, okay, it's like not always, it's not going to fill up your entire RAM memory if you play for a really long time. Anyway, let's remove the pointer trails. That was just showing off what you could use a ring buffer for. So let's implement it. Right? We have the head pointer. Well, it's not going to be the pointer. I just call it pointer because it's like a thing that points into an element. But actually, my element pointer is basically going to be the index. So we're going to have 2 indexes. We're of course going to have a pointer to the data. We're going to have the maximum capacity, and I'm going to keep the track of the size as well. So let's begin. After 1.5 hours of streaming, let's create a new class. Okay. I'm just gonna go in here, and I'm gonna say, wait, should I do it like this? I guess. Add new item, and I'm simply going to call it ring buffer with a underscore. Okay, and that's going to be H because it's going to be a template. Okay, so here we go. We have the pragma once pragma, so that it doesn't redefine in other objects. And I'm going to start by creating a class. Class called a ring buffer, and and of course this is going to be a template. This is how you write template. That's going to be a type name of T, right? So you can have a ring buffer of anything that you wish. Okay, so first thing that I'm going to have, I do call it a class, but actually I'm going to make everything public. The reason for that is that I'm a solo developer. I know what the internals are. I don't need to hide anything. But I just call this a class because a struct is usually something that is light and small and is basic data thing that doesn't have constructors and destructors. That's how I kind of defer them. Kind of like how you would use them in C#. But in C#, of course, the classes are heap allocated automatically and reference counted. Managed. That's what I wanted to say. While structs are inline, right? So C++ doesn't have that difference. The only difference between structs and classes in C++ is that structs are public by default. That's it. And classes are private by default. But anyway, yeah, that's just the reasoning between for me calling this a class, right? Okay, so as I said, we're going to have some kind of data pointer, right? And that's going to be the pointer to the t, basically. That's going to be called data. I don't know, should I call data or should I call it, I always call it data. Yeah, I'm going to keep calling it sometimes they're called pointer or something. But yeah, let's call it data. And now I'm going to have the head, right? Which is going to be an index, right? It's going to be the size t. And I'm going to call it, what is it? The head, and size t, the tail, right? Okay. And then one more thing that I need to have is capacity, and I'm gonna also have the size. And I'm not going to use a vector, right? I'm going to directly point into the data, because this is how I prefer to do these collections. And yeah, we're gonna start by having a void which is going to create. But here's the thing. I want to be able to create a ring buffer. I want to be able to allocate it on the heap, but I also want to make it possible for it to work on local data. And how do you do that, right? How do you make this possible? Well, in C++, you can't do that. And I can just point a custom pointer, right? Point to the data. And yeah, so maybe instead of calling this init, I might call this allocate, alloc heap or something like that. I don't know. I'm not sure about the naming, but this is more. This makes more sense, right? When you see it, you know that it should be that one. And here I'm gonna turn this into. I'm gonna use malloc, but I haven't included. Yeah, first thing that I'm gonna include is cassert, which is the assertion. And then we have the malloc. Where is actually malloc? Is it malloc h? Maybe. Okay, and I'm just simply going to allocate the size of. I don't have to actually repeat this because I already have that. But yeah, since I'm streaming, let's do it. So the malloc, what it does is that it allocates bytes on the heap, right? It's the most basic function in C, basically. It just gives you a piece of memory, right? The operating system gives you a piece of memory on the heap. And yeah, in this case, this is going to be the size of t multiplied by capacity, right? But here's the thing. I am actually going to pass in capacity as a argument so that I don't forget to set it. And I'm going to set it here, right? Okay. So this is going to be allocated on the heap. But as I said, I want to be able to also allocate it locally. So I don't know if I should call it this alloc local or something, or maybe I should just say init local or set buffer or something. So instead of allocating, you can set a custom buffer. Yeah, maybe set buffer would be something like that. So yeah, I can just take a pointer to the data, something like that. Oh wait, let's call this buffer actually, and I'm gonna make that data is the buffer, although I'm not doing anything, right? I could have actually just set it outside, but yeah, let's just keep it as a function. Okay, well, now of course, what are the most important things that we need? We need to be able to push. We need to be able to push it on the back, right? We're gonna need to push on the front, right? We're gonna need to pop on the back, which is the this side, right? Well, if the pointer is pointing here, well, it should be pointing here. Okay, let's move the 4 away, right? So we need to pop right from the back, and we need to be able to pop from the front, and also add from the front. Okay, so I'm just gonna call this push pop back and pop front, right? And what these are going to do is these should actually return me the t, right? Because they're no longer in the, yeah, they should be returning the copy of the object, hopefully. And pushing, I should actually put a object inside. So should I call it just the tt? And these can also be const references, because I actually have no idea how big they are. Maybe they're really big. So yeah, I'm just going to put them as a const reference. So yeah, what do these do, right? And what else am I going to need? Let's see. Oh yeah, I'm definitely going to need to have some kind of yeah, I should be able to. Okay, there's definitely going to be is empty, right? This is going to actually return the size 0. I'm gonna have the is full just because I have those in everywhere in all my collections. Size equals capacity, right? But we can actually put size more than equals capacity, just in case. It should never happen, but just in case, right? Okay. And yeah, and that's basically it to begin with, right? Okay, let's start implementing these. So, by the way, these should be initialized. They should all be initialized. I'm going to start with null pointer, and these should be 0 and 0. As I said, if the thing is empty, right, they should point into the same position, and that's going to be the 0, right? The 0 thing. The 0 function. The 0 function. The first element, which is the 0. And I am going to also initialize capacity to 0. I'm going to initialize the size to size, but I'm thinking maybe the capacity can be const. That means that I would need to have a ring buffer. I would need to have a constructor for the ring buffer. Yeah, let's think about it later. Yeah, which means that if I want to create a ring buffer, I would need to initialize it as well. I wouldn't be able to just have like a ring buffer that exists in line. It would need to, yeah. But a const would actually give some benefits to the compiler, because anything you make const is going to be compiler friendly. It's going to be optimizable, which is always good to have. But you never know. Yeah, I'm definitely not gonna change the capacity. That's the thing. Because if I want to change the capacity, I probably want a new ring buffer. That's what I'm thinking about, making this a const. But let's not think about constness yet. Right? Okay. Yeah, and in that case, I would move this capacity to the heap, right? To the constructor. Okay. So, by the way, this data should actually static cast into t pointer, right? Because we are just malloc-ing a void pointer. Malloc actually returns you a void pointer, right? So you need to convert it. Okay, so that's about it. So what happens when you push back? When you push back an item? Well, okay, let's see. What happens is that we are going to put the element into the first element, right? Into the first thing, right? If I don't have one anymore. I deleted it accidentally. I'm gonna put it here, and then I'm gonna move the head. This is the tail, right? No, this is the head. Okay, let's do the head. Let's say that the head is blue. But I think I actually used this thing as the head before. Yeah, doesn't matter. This is the head, right? So we move the head forward, which is basically that, which is basically what I have, right? So data head, right? The data at the head becomes t, okay? And the head gets incremented. That's basically it, right? And you know what? It would be actually practical to get a pointer, to get a reference to that element. So I can just do this and return data at head -1. Is this a good way to write it? I could actually increment it in here. But that's really bad practice. I really recommend not doing this. The only reason why you would do this is if you want to put it in a return like this, but so that it just gets incremented after return. But this is also bad practice in my opinion. I think that the compiler is going to optimize this anyway. These are such simple things for the compiler. I think that that's probably going to be optimized. So yeah, you move the head forward and return the head. Okay, so that should theoretically work, right? At least in the beginning. But we need to think about what happens when the head goes overboard. What happens when it goes over capacity, right? If we start putting stuff in, everything works, right? Everything is fine. We put that at the head. But now we're gonna put more things. Okay, let's make a copy of this and let's remove this arrow because it's not doing anything. It's just like hanging out on the side. We put more things. Oh, well, in this case, we actually have this one. Okay. And now it's got fucked. Okay. Yeah. So let's just copy these. Okay. 1, 2, 3. We have 4. And what happens is that the head goes beyond, right? Goes beyond the size. Oh yeah, by the way, let me tag these. Let me put the indices so that just makes it easier to reason about because I was using, yeah, something like this, right? Oh, well, I could actually make a copy of it just so that I have it here. Okay. So these are just the indices, right? So this is the The 0th element, the first, the 1 element, the 2, the 3 element, right? That's just what I'm showing with these numbers. Yeah, so when the index is at 4, right? This is the 4 element, which doesn't exist. But 4 is exactly the size. So when it is equal or higher than 4, than the size, well, which, it should never be bigger. That means that it's at the end, right? It's at the end. And what we have to do, in case we push another one, we need to wrap it around. And so I need to have in mind that yes. So if in case, so yeah, I have to put it in front. If head is more or equal the size, the capacity, because that's the total. If it is higher, then head should become 0, right? We should move. So yeah, at the beginning, right, we want to add a new one, move the head to the front, and that becomes 0, right? Head now becomes 0. And what happens, head becomes 0, data is 0. We set this one, and we also increment the head. So head will actually move here. That's good. That's good, because that's the next element we need to change. Okay, but we're going to have a problem with the tail, which I'm going to do next. But for now, this should work, right? We should be able to push back things forever. And they're going to override. Okay, so let me make a little test here. Okay, at the end of the whole thing, this is the main, by the way, this is the main function, which is where I'm testing everything. So if I run this, can't you implement ring buffer simply with modulo? I think modulo takes care of most of the ring buffer requirements. That's a good idea, I didn't think about it, right? Does it, instead of all that code and the push, you can just compute index modulo and it will automatically wrap for you. Yeah, that's actually true. Okay, yeah, this works. I have some destroyed allocations, blah, 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 but that's not important. For now, I just want to, let's make a new scope. This is where I'm going to do my, let's do instead of a fixed vector, let's put a ring buffer. Okay. Ring buffer. And yeah, so I need to include it. I need to include the ring buffer. There it is. And I'm going to make a ring buffer of type, let's just do an int. And let's just call it buffer. Buffer push. Yeah, push back. That should work. I'm going to push back 1. Right? I'm going to push back 1. And let's just push a few of those. But for each of the pushes, by the way, yes, of course, I need to allocate it first. Don't forget about that, right? I am going to allocate 4, the capacity. So that's going to be on the heap for now. Push back, push 3 of them. And that should work, right? And here's what I'm going to do as well. I'm going to make a little, how did I do this? How did I do this? Output thing. I have to remember killing add stack vector, because I have this, if I run in place back, I have to remember how did I do this after push. What did I do here? Debug. Ah, there it is. Test struct. No, this is not it, I think. Yeah, this is just the struct itself. This is a test struct. The reason why I have this test struct is to test, when it's getting created, when it's getting destroyed, and stuff like that. But no, I actually have a debugger somewhere. Oh, there it is. Ah, set width, right? I forgot about that one. Create a walk input with capacity. Yes, output pool. Aha, this is how I was doing this. Is this the whole lambda? Yeah, it is. Okay, let's copy this, and I'm gonna do an output of the ring buffer. Oh, what is going on here? Unknown escape sequence R. Oh, this should be an N. Okay. Output. Let's call this output ring buffer. Okay, that's a little lambda. I'm gonna, for each of the, oh yeah, I do actually have a buffer here. So let's mention it here first. I'm gonna have the buffer. You know what? Let's pass it in. Let's pass the ring buffer in. It's gonna be a reference. Oh shit! This needs to be a template because I have a ring buffer. Okay, doesn't matter. I'm just gonna pass in a buffer, like this. Okay, so yeah, there's no is alive. Instead, I'm just outputting whatever. Yeah, I also need to somehow show where the head and the foot is, or the tail, which would be interesting. But yeah, buffer size. What am I doing here? Pool. Yeah, pool I. I'm just going to. Well, yeah, that's not the pool. It's the buffer. Okay. Of course, I don't have the indexer. I don't have the indexer. So what I need to do is I need to get the data. And then I'm going to output this data. I wonder what it's going to be if, yeah, maybe I would need to initialize the buffer. Yeah, it's probably going to be gibberish, right? So let's see. Let's see what happens. Okay, I'm going to just call the output ring buffer at the end. And let's see what happens. The last element is probably going to be gibberish. Nice. There's nothing. Okay, what am I doing? What am I doing here? A ring buffer. Okay, sorry. Let's see. Hello there. Happy New Year. Yeah, hello there. Farfa Day. Happy New Year as well. All right. Yeah, ring buffer with modulos. I'm gonna go look at that. Instead of all that code in a push, you can just compute index modulo and it will automatically buffer you. Yeah, that makes sense. I don't need to do an if. Are you intentionally avoiding constructors? I'm intentionally avoiding constructors. It's not intentional. It's just I feel like constructors add a complexity, and it's easier for me to reason about code when it doesn't have constructors and destructors but I'm definitely going to have to implement constructors for. Also, it's like if you don't have a constructor, then you can't put a thing in a global. And when you have constructors, I mean, it gets harder to put things in a global space, somewhere here, right? Like in my case, I can just do this, right? And that's it. I don't need to initialize the size. I don't need to initialize anything. I can initialize that later, right? Yeah, and I can just change the pointer later. But yeah, of course, it is less safe. It's less safe, and yeah, the problem is that it's also like it depends if the containing classes are gonna have constructors or not. That I'm gonna think about that later. But for now, I always prefer not having constructor. If I can avoid them, that's great. Even if it has a constructor, it will work in global namespace. Yeah, I know. But then, for example, I can't reuse. Okay. The problem is allocating. What if I want to use a ring buffer to point into local, into memory on the stack? That's what I want to do. I don't want to create a separate object that yeah, for example, in this case I'm allocating on the heap, right? But in this case I can set any buffer, so this buffer could even be on the stack. Yeah, this is why, like, if I would move this into a constructor, right, then it means that it's always going to malloc something. Well, it doesn't have to, but yeah, at least I can set the capacity or something like that. Yeah. Well, I can always have multiple constructors, one which points into the data, into the local data. One which allocates its own heap thing. But you can pass in a boolean or something. Yeah, you could even have it as a template parameter. I mean, I could even have like a bool allocate on here. I could even have that, and then it will create two different ring buffers, depending on how I want to use it or something. But yeah, let's first implement, a working ring buffer, and then I'm going to think about the how do you call it, the menialities, the menial stuff. Yeah, okay. Anyway, the trivialities. By the way, yeah, let me read the rest. I didn't read anything. You could have just passed in ring buffer int if you didn't care about the lambda being generic. Yeah, I mean, I could, right? But yeah, it's okay for now. Depending on which alloc you used, if you use calloc, it will be zeroed. Is it? I didn't know that. I don't think I ever used calloc. Count size. What's the difference? What do you mean count? Count of what? Is this also, malloc is just a single thing. It's just a size. And what's a calloc? Count and size. Allocates memory for an array or a number of objects of size. Oh, okay, so it's basically the same. It's basically like moving the size of t to a separate thing initializes all bytes in the allocated storage to 0. Returns the pointer to the lowest byte that is suitably aligned for any object type. Okay, if size is 0, the behavior is implementation defined. Okay, so it's better than malloc, I guess. Maybe I should use it. Maybe I should use it instead. So I could just use calloc and then have a capacity and a size of t, right? Let's see if that works. No, for some reason it's not displaying. Okay, what is going on? I have some kind of a bug here. I am pushing in the data, right? Buffer size. Ah, it's the size. It's not the size, it's the capacity that I need. I think that's the problem, probably. Yeah, there it is. 1, 2, 3, 0. Okay. So yeah, cool. We have something. We have a little bit of a display of the ring buffer. Okay, let's see. Sorry, I didn't mean to sound like I'm backseating. But a constructor is perfect here. That's fine. Backseating is fine on the stream. But a constructor is perfect here. Your alloc heap can be replaced with a simple constructor. Even if it has a constructor, it will work in global namespaces as well. Same goes if you use a constructor. But yes, it will always alloc. But you can pass in a boolean or something. Yep. Ring buffer, T buffer, and rung buffer. Rung buffer size T capacity. I know it's probably a typo, but it's funny. Rung buffer. Ring buffer and rung buffer. Two constructors for the two use cases. Yeah, that's exactly what I was, what I already mentioned without reading the chat. Calloc allocates plus zeros out the memory. You call it like this. Calloc one size of thing. Yeah. Calloc wants to know how many because it zeros all the elements you allocate. Yes, calloc capacity size of t. Yes. Okay. Oh, by the way, let's go back to malloc and let's see now if there's going to be gibberish at the end. Here we go. Yes, it's gibberish. We got it. We got gibberish. Yeah. So malloc obviously shows that, this is not initialized. Okay. Well, I guess I don't know. Whatever. Guess I can use whatever. I'm guessing malloc is slightly faster, but probably not gonna be ever an issue. Okay, so yeah, pushing back. I don't need to do this as has been said. What I could do is I could simply use a modulo. Is there a modulo equals? Does this exist in C++? Right? If I do this, that should probably work, right? Or is it +1? More than capacity. Yeah, I think this should work. I'm always confused about +1s, -1s. Okay, well, let's see if this works. Yeah, of course, because if it matches capacity, it's going to be 0, which is exactly what I need, right? Okay, it works for now. Okay, so what I'm gonna do is I'm gonna push more, right? I'm gonna push more, and you know what? I can just use a for loop, right? I can just do a for, let's do it 5, and I'm gonna buffer push back I. And this I'm gonna make into an int, so it doesn't complain. Okay. Yeah, let's see what happens if I push 5 of them, right? Is it gonna output data head plus plus equals good? Oh my god, this is the worst thing. Yeah, there it is. 0 has been overridden. So 0, 1, 2, 3, and 4. Oh my god. Please no. Data head plus plus capacity equals t. My god, that's the worst. Yeah, this is now it becomes completely unreadable, you know. I have to think about it, like what is going on here. But no, I'm just gonna keep it like this. I'm pretty sure that the compiler is going to optimize this. I hope so. All right. So, yeah. Also, I mean, I'm returning data with a -1, which here's the thing. I could do this, right? This would be nicer, but I feel so bad about this, about doing a plus plus inside a function. It's like inside an indexer. Ugh. It feels painful. I don't know. I'm just gonna keep this. This is definitely more readable. Yeah. I don't like doing arithmetic inside functions, inside parameters and stuff. It just feels like, you know, a gun about to shoot into the foot. Okay, so that works, right? But here's the thing, is that if we're pushing back, we have the foot. Oh yeah, let's visualize where the foot and the thing is. So I need to somehow make a parallel universe here. I'm gonna do another one of these, and I'm gonna split them with the new line. Okay, and actually I don't need no, I do need this. Okay. Okay, so this is what I'm gonna do, right? I'm gonna say, if buffer head equals I, I'm gonna output code. I'm gonna say this is gonna be head. Okay, and yeah, this is not gonna work probably, right? Because this is I'm reserving 3 here. Do I actually have to do it twice? I don't know. Let's see if this works. Maybe it's not gonna work. I am confused about the buffer. Okay, else if it's a foot, tail, that's gonna be the tail, right? Okay, let's see if this works. Oh, and you know, it's actually not gonna work if they're both at the same time. But here we sort of see this is the head is over here, the tail is over here. That's good. That's perfect. Okay. And you know what? Let's not put let's just make it H and T, right? So here's the thing. If it's a, oh yeah, let's not do an else. I'm just gonna do an if, right? And if I do an if, then if they're at the same position, yeah, it is a bit annoying that I'm okay, well, here, let's actually hide all this. Can I just use a, yeah, maybe I can. Okay, let's just disable these, the whole thing before the ring buffer, so that they don't have to compile and wait for everything. Okay, so I have the H and the T. And let's just do output the ring buffer before everything, right? There it is. We have it fast, and there we go. H and T, the head and the tail are at the same position. Let's put actually the tail before. There it is. The tail and the head are on the same page, right? For some reason they're not aligned. They're not aligned with the rest. That's because I'm adding these the dot. I can't even remember why am I doing this. Set with, yeah. Maybe I'm doing something wrong with this set width, because I think what this does is like it pre-allocates 3 of those. Like in this case, like it's 0. And then it will fill it up. Yeah. And then in this case, it doesn't do anything. Yeah, the tail is here, the head is here, but in those which are nothing, okay, let's just do this. If it's not, and buffer head is not I, then just add nothing. I wonder if this is going to work. Kind of. They are a bit offset now for the TH, but doesn't matter, you know, because this is the only this is the only case where it's gonna matter. And for some reason there's no bar at the end, even though I have it. Oh well, it should be here. Okay. Anyway, at least we know where the tail and the head are now. Yeah, and why do I have these two? I can't even remember why I have these two. What if I just do this? Was it trying to center something? I don't know. Okay, yeah. Well, let's just do this. Maybe I can do like a colon for more aesthetics. Yeah, something like that. And I still have, but now there's actually 2 places, which I'm confused about. Anyway, it doesn't matter. What matters is that I can see where the tail and the head are, right? And in this case, it is correct, right? The tail is here. But here's the thing. We moved, okay. Here's what I'm gonna do. I'm gonna do a 3. And let's not do nothing. And I'm gonna do another, you know what? I can just do this, you know? I can just put a 5. And I'm gonna output every time. So here's what is happening, right? We have the whole sequence. Let me just zoom in, by the way, so that you can see the whole thing. So we have the tail and the head. The head moves. This is 0 is inserted, except that, yeah, it's 0, so we don't see it. The head moves. 1 is inserted. Head moves, and 2 is inserted at the head's position. And then head disappears. Head disappears because head is here, which means that it's completely full, right? The buffer is full. And then what happens if we wrap it around? We wrap the head around as shown with the modulo. We put the 4 and then we move the head forward. But here's the problem. The tail stays in here. The tail should be in here. The tail should be at the 1 because this is not the tail anymore. So in this case, we need to move the tail, right? That's our issue. And in this case, we keep on. Oh yeah, we don't keep on. Okay, let's put more. Let's put 10 times, right? So we're basically going to keep overriding things. Oh, I need to press enter. Yeah, there it is. So we're moving the tail, we're moving the head. The tail stays. Nothing happens. Head goes forward, head, right? But yeah, the tail should be moving as well with the head because it's full. So when we override. Okay. And this is what we need to do now. So, yeah, not the output, but let's go back. Let's put these together. Okay, yeah. Okay, so when should I move the tail, right? I should move the tail when the head. So yeah, let's look at the data again. Let's look at the data. What does it say? What does it say? The head moves in. The head moves over here. Tail stays. Head moves to 0. And now in this case, right, the tail and the head are in the same position. So that's where it should move, right? If tail equals head, right? Move the tail forward. Tail plus plus. But this is also incorrect, right? Because tail should also wrap around. But let's test this one. Let's test this one out. So when the head moves forward, there we go. Oh, oh, look at that. Look at this mistake we made, right? We are moving the head at the beginning, the tail at the beginning. That's totally incorrect. And why is that? Because there's a special case when the buffer is empty. When the buffer is empty, the tail should not move, right? So I need to say and size is 0 and size is not 0. But here's the thing. We also need to advance the size because, yeah, because the size is 0. So when we're filling up stuff, we need to increase the size. But also, size is not 0, right? Actually, this should happen here because the size changes. The size changes when we move the tail. And when we don't move the tail, right? Because when we move the tail, the buffer is actually stays the same size, right? So the size should, okay, let's output the size as well so that we're sure that it doesn't change. Let's here say std cout, I'm gonna say size. I'm gonna put a size is buffer size. There we go. Something like this. So now when we output everything, it should show the size. There it is. 0, 1, 2, 3, 4, and it stays. It stays forever here. And why did the tail? Yes, yeah. So here it is. We have it correct. The head has moved. The tail doesn't because the size was 0. We increased the size, and then when it gets to the end, the size doesn't move. The size doesn't. There's no more size. And when it does flip around, it moves the tail. So it moves the tail forward, moves the tail forward. And what happens here? What happens in here? Where's the tail? Where did the tail go? The tail was just stuck beyond here. And then it never moved. In this case, right? We need to handle this case as well because the tail needs to move, and the tail is moving again with the modulo, right? So the tail plus plus, but tail should also be like capacity. Capacity. Okay, there we go. There we go. And now it works. The head moves. The in this case, the head is over here beyond. It's full. Buffer is full. The head moves, wraps around, and moves the tail. And now the beginning is here, right? The beginning is here, and the end is here because it goes beyond. And then when we add the 5, we move the tail and the head here. We finally move the tail and the head. The tail and the head. Oh, the tail goes beyond the tail and the head, and that's it. Okay. So here we go. Right? What is going on here? Oh, this is just the final one, which is just the repeat. I'm thinking now that the size is basically the same as the tail. But yeah, we have to keep track of the tail, actually. Do we have to keep track of the tail? Maybe I can just keep the size instead of the tail position, because the tail is then head plus the size. Maybe that's like an optimization, but maybe that's worse for the memory or the performance, right? Maybe I should keep the tail as well. And the size. Yeah, I don't know, because if the size is 4, right, I'm absolutely sure that the tail and the head are going to be in the same position. And if the size is 0, I also know that they're going to be at the same index. So yeah, it is an interesting thing to think about. But then if I'm looping through, right, I need to looping through this buffer is now relatively easy because I just until I encounter the tail, I go from the tail and until I encounter the head. That's what I meant. Until I encounter the head, I stop. In this case, I would need to calculate where is the tail, calculate where is the, yeah, well, maybe that's not such a bad thing. Okay, so pushing works, right? Pushing works. Pushing into works now with the tail as well. All right, so what about popping? Let's try popping. Or should I do the pushing in the front first? Because then we move the tail. Pushing in the front is basic. Yeah, the pushing and popping in the front is just going to be this thing but reversed. Yeah. And pushing in the front. Yeah, let's do a pop. So pop back. I think we're... Yeah, maybe I can also add this, like, make a ring buffer class. Okay, what is a ring buffer? I did explain it. Make a ring buffer class, done. Implement pushing. Pushing back, right? Done. Implement popping back. And then, in the next thing, I'm just going to be implement pushing and popping front, right? Finally, I'm gonna make an iterator for range 4, so that I can easily iterate through. Oh, I need to have an indexer as well. Implement an indexer. I don't need to say implement every time. It is indexer. Okay, it is quite telling iterator. Okay, and then I'm going to be able to use it, I guess. All right, so how does popping work, right? Well, first off, I need to assert that it's not empty, right? Because if it is empty, it should work, right? That should be telling. So you can't pop from an empty thing, right? That's one thing. Second thing is that basically I decrement the head, right? What's popping, by the way? Did I even explain it? Yeah. So you have things pushed, right, like this. The head is over here, and what I need to do is I need to move the head back and take the 3 and return it to the caller, to whoever uses the buffer, right? And I, of course, remove it. And here is what is going to happen, right? I pop it back. I move the head back, right? And then when I move the head back, this is where my item resides, right? So I'm simply going to return a T. No, what? I'm going to return data head, right? Okay, but of course, it's not that simple, because what if the head is on the beginning? Here is a special case where everything is full. Okay, let's do it like this. I'm going to copy this. It's full, and I pop. Okay, yeah, when it's full, what I do is it's beyond the bounds. I simply pop back. That's fine. But what if I add a 5th element, right? I add number 5 instead of 1. Yeah, let's just make it a 5, right? And what happens in this case, as we have seen, we are going to move the head back. And then, since the head and the tail are in the same position, at the end, I move them like this, right? So this is the situation where I have an item that is here. So it starts, my ring buffer now starts from 2, 3, 4, 5, right? That's how it goes, and it ends at a head. And in this case, if I want to pop, right, I have my beautiful head here. And I move the head back, right? I pop this, return it to the caller. But here's the thing. The head... Oh, no, this is actually correct. Wait a minute. How does this work? Okay, wait. Oh, right. This is how it works. The head actually can't ever be at 0. I just realized. The head needs to be over here. Yeah, so if the head is at 0, if head is at 0, it needs to go ahead. It needs to go forward, right? It needs to go to capacity side. Yeah. Here is what happens, right? Because this needs to now pop over here. Which is exactly... Oh, no, I don't have that situation, right? But, yeah, that's the thing. So that I can push in another one. And is that easy? Of course. I need to get the data before this happens. How do I do this? Do I grab a reference to it and then return it? I make a copy for no reason. I could make a copy for no reason, but then... Yeah, it would be great to be able to like increment post doing this. Maybe now I can use that trick. That push Q or DX suggested. I wonder though if this is gonna work. What about negative numbers? How does it actually modulo negative numbers? That's always a that's always something you can't rely on. You know what? Let's not do this. Let's not do this. Instead, I'm just gonna get the T, you know. And then I'm going to return the T. Yeah, that's how we're going to do this. But yeah, maybe I can... Wait, where's my... Did I just quit Mozilla? Oh, no. It actually crashed. Cool. Firefox crashed. Nice. Okay. Yeah, I wonder if this would work with the modulo. I'm not sure exactly. But yeah, this is fairly simple. Also, maybe the compiler would optimize this. Yeah. Well, there's one thing. I can try it. You know. So let's do a single pop after this. Buffer pop back. Okay, let's do a single pop. And now we're gonna output at the end. So let's see what happens. Let's see what happens. Boom. Okay, the head has gone down. Oh yeah, of course. The element is still 9 because I'm not destroying it. But it is good. It is good. It's good that head has moved. Oh, look at that. The size is 4. Right, another thing that I need to make sure is that the size needs to decrement. Okay, there it is. Okay, we know that the size is 3. We move the head back. Okay, so let's do it multiple times now. Let's pop it. Let's pop it 3 times. What happens? What happens 3 times? Boom, we go back. That's... Wait a minute. We have a head and a tail. The head goes beyond. Tail... What? What's going on here? Wait. We have the tail, we have the head, we have the head, we have the head. And then boom. The tail jumps to the beginning. That's good. The head is here. And then the head pushes the tail. And then the tail and the head are here. And then I start dealing. Oh yeah, of course. I didn't actually put a. I didn't actually output like this. I mean, silly programming, but let's see. Okay, so yeah, there it is. The head moves back. The head moves back and is at 0. But if it's at 0, it pops back, right? And the head pops back, and now there's only one element. There's only 6, although, you know, these are visible, but they don't actually exist. Okay, and then we can do another pop. And what happens now is that it should be empty, right? It should be empty after this one. Oh, did I actually? Yeah, I did output. Okay, at the end, the size is 0. There it is. The tail and the head are at index 2. But nothing is in the buffer. And what happens if I attempt to pop back again? If I attempt, boom, perfect. Yeah, of course, it should be an error. It should be an error. And if I say retry, it goes assert is empty. By the way, does anybody know why do always breakpoints show up one line afterwards? That is extremely annoying. Why doesn't it just show me it here? And you know, sometimes I'm confused you know, but now I'm used to it. But in the beginning, when I was starting out with C++, I was like, what is in this line? What's going on? And then I'm like, oh, it's actually the previous line that broke. Yeah, so there it is. There it is. It has broken. It has broken. All right. That is intended. That is completely intended. Okay, let's try to push a few things again. And let's see if everything works fine. Looks good. Looks good. So this is where we started. We start popping, pop, 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 pop. And this is empty. And then we push again. We push more. We push a 0. There it is. 0, 1, 2. And then we have a 3. And then we have a 4. And then we have a 5. And then we have 7. And then we have 7. 6 and 7 and 8 and 9 and so on. Perfect. Okay, so popping and pushing works. That's nice. That's nice. Yeah. The only thing I don't like is this temporary. This temporary here. Maybe I could just return data with the old head. Yeah, what if I just keep a temporary to the size t of old head? And I'm going to keep the head. And I'm just going to return the data old head. That's going to be the thing, right? So I remembered which is the old one. And I mean, the only thing I have now is I've introduced this local, but that's better than, you know, keeping a temporary of who knows what. So maybe this, yeah, maybe this t is like some kind of gigantic thing. So it would be great to just return. Cool. Okay. So that's nice. We have popping front, popping back, pushing and popping. Okay, and now we should just reverse the whole thing, reverse the technology, and just do, by the way, I don't need this shakedown anymore. I can just delete everything. Yeah, something like this. And I don't need everything either. Yeah, but I don't know why Firefox crashed. Didn't like something. Okay, pushing and popping front. I'm slowly getting hungry, by the way, even though I ate just before starting a stream. Which was, well, it was 3.5 hours or something ago. Okay. Wrong buffer. So yeah, let's reverse the whole thing and do a pop back. Old head. Yeah, it's always going to be... Okay, let's compress this a bit. Maybe I can do a size. Size is gonna always go down no matter what. So I'll just put it in front. This is definitely gonna, yeah, it's not gonna error or anything. It shouldn't before. If it errors, it might error here, but I don't think so. Okay, let's repurpose pushing for the front. So what is going to happen is that basically we have the same stuff, except that the tail moves. So in these cases, the head was always moving, right? The head was moving. But in our case of popping and pushing, the tail now moves. So it's basically the same thing except reversed. What I can do is I can simply copy the whole thing, but I'm not going to do it. I'm just going to look at it and rewrite, right? So first thing is that the tail is always going to be the multiple of... This is now a question, because I don't know what happens if it goes negative, but we'll see. We'll see soon. Okay. If the tail, in this case, if we have this exact same thing, right? If this tail is the head and size is not 0, then the head should move back, right? The head should move back. In the case of the tail, it is the head, right? So what's this case? This case is when everything is full. When everything is full, let's try to do this. Everything is full, and we have the same pointer, right, at the same time. And what we do is we push another thing to the tail. So we move the tail, and then we put the number in. And we are going to also move the head. No, wait, sorry. Sorry, the tail moves backwards. Yeah, the tail moves backwards, which means that the head needs to move backwards as well, because we have erased this object. Yeah, it's a bit hard to like imagine this now. Okay, so but there is a difference. There is a difference between the head, because the head is a head, and the tail is at the index that we need to do. So we actually need to get the object first, right? Yeah, instead of moving it. So that's a slight difference between the head and the tail. You can see it in this case. Like, this is where the buffer is. Yeah, like we have a 1 here and a 2 here, but the tail sits on top of this 0 of the first element, right? But the head, it doesn't sit on top of the last element. It's actually 1 beyond. So that's a slight difference. Like, I could have also made it like this, but I don't know. It feels to me a little bit more logical to have it ahead than behind. Okay, so what actually, when I push, what I actually need to do is I need to decrement the tail first, right? Because when pushing in front, and then I check if it's in the capacity, and then if it's -1, it should go to 4. I actually need to check if modulo, how is it implemented in C++? Is it, what is the negative numbers, right? How does it reflect? Can I see a graph? Can I see a graph? Okay, well, I see this, but modulus with negative numbers. What the hell? It just downloaded the HTML. Fuck you. Modulus with negative numbers in C++. The output should be answer, word force approach. The thing is that isn't the module operator, but the division remainder operator with the following equality. So, in case your integer division rounds towards 0, which is mandated, I think -5 by 4 will be -1. Oh my god. So -5 is the -1 and not a wrapping modulus. Yeah, this is why I'm not... Is there an std mod? Okay, there's a mod. What about? No. Yeah, this is why I'm not very keen on using the modulo. I knew it. I knew there is some kind of a caveat to that. And also, modulo operator is slightly expensive. That's, I remember. Yeah, also in shaders. In shaders, it's the worst thing. That's what I heard at least. Modulo for negative numbers. C++ modulo. Okay. Jesus. You know what? I'm just gonna wrap it myself. I'm just gonna wrap it myself. But here's the problem, right? There's a little bit of a problem. I just realized. I just realized that I just realized that this is a size T. So it's actually going to underflow beyond 0. It's not going to be -1. And you know what? Oh yeah, I don't actually have a problem here because it's 0. But tail does have a problem. Yeah, so actually it is a bit different. Push front. Because I have to check. I have to check the tail. If tail is 0, then I'm gonna skip. I'm gonna skip decreasing it. Yeah, I'm gonna just go straight to capacity -1. And it's capacity -1 because it shouldn't. Yeah, because it shouldn't wrap. Yeah, then we can delete this. And I say if the tail is head, size is 0, head is minus. Yeah. But in case it's 0, in case the tail becomes 0, it's impossible for the head to be. Yeah, there is a problem there. There's definitely a problem there that I need to handle. Data head is T. There's probably a more elegant solution to this, but I'm gonna keep being ignorant. Also, I need to grab a little snack or something. Okay, I'll be back. Hmm. Hmm. Yeah. So let's look at this. At this edge case. Okay, let's do another one. I have a thing that is full, right? This is my head. This is my tail. They're at the same point. But what I do is I'm gonna add an element. But here's the thing. If I add an element to the tail, the head moves as well. But the head should actually move here. That's the thing, because it's no longer, yeah. So this is also in the case the tail is 0. In the case, oh right, but I should also check it if the tail is 0. If the tail is 0, whoops. So yeah, when should it actually move? Oh right. Yeah, but I actually need to check if it's this is so complicated now because I'm actually moving the tail already in the beginning. So I actually have to reverse the whole thing now that I think about it. So I should put this above as well. If tail is the head, like in this case, right? I move the head down. I'm gonna move the head down. But if the head is 0, the head needs to be capacity. That's the thing. It needs to pop over here. And then what I do is I move and then what I do is if the tail is 0, right, it's not 0. I move the capacity. No, I'm going to move the tail to 0. That's the thing, right? And then, okay, we do it again, right? We push the tail. Okay, so I say tail is the head, it's not. Size is not 0, it's not 0. I move the head. Oh yeah, I do nothing here. Well, here's the problem. Wait, tail is the head. Tail is the head. In this case it is. Oh my god. It's so complicated. Okay, well this is what it should be. Or tail is 0 and there's a special case where tail is 0 and head is capacity. So yeah, this is where I made it complicated by having the head ahead, right? Because this is a special case of, okay, they were together, but now when I moved it down, they're not together anymore. So this is a special case. Yeah, I still need to offset the head. So I move it to 4. And yeah, the head is not at 0, so that's fine. But if tail is 0, in this case, yeah, it is 0, then the tail is capacity minus 1. There it is. So yeah, this is how we wrap around. Oh my god. Wait, we need to put this one in the, wait. If tail is 0 and, yeah, well, this is unfortunate. This is a terrible, terrible. Yeah, that is why it makes actually more sense to wrap the tail around. Maybe I can do that. right? What if but I need to do it at the end. That's the problem. My God. C++ very crazy. It's not just craziness of C++. I mean, this would be implemented in any language, but just, yeah. It's me that doesn't have experience with ring buffers, just naively trying to implement it. Okay, if you move this one, okay, they're at the back. They're at the back. Okay, what if I just naively move the tail back? Ah, yeah. The problem is the minus. That's the problem. Yeah, what if I move it to the back though? To the capacity. Okay, let's imagine it a little bit different. In case this fails, I'm just making a copy. Push front 2, right? So, okay, this is what I'm gonna do. I'm gonna move the tail back. Tail minus minus. But because minus doesn't work, I need to check if tail is 0. And instead of putting it to capacity minus 1, I'm gonna put it to capacity. Right? And else tail minus minus, right? So if it's not an 0, then okay. In this case, I move it to back, right? Okay, but now I also need to make sure that, wait, in this case it wasn't at the same. There's another problem, right? This is not matching tail and head, but they can be matching in this case. Right? Oh, Jesus. I was actually close to the solution here, but just this pool is awful. Okay, so if the tail is 0, I move the tail to the capacity. Tail minus minus. Okay, but then I need to check. Ah, I know it. I know what's up. This is the thing, right? In this case, it's full. The buffer is full, and I move it back. Well, I move it across. This is why I want it. Yes. Is it? Is it though? Is it though? Because what in this case? What if in this case? Right? Okay, well, let's try this. Okay, I move the tail. Yeah, I say tail is 0. It's not 0. Okay, I move the tail back. I move the tail back. But I should move the head back as well. Oh, I know. If head is tail plus 1. There we go. I think this actually solves it, because then I can do this. Okay, so I decrement the tail, right? And I say, well, if head is tail plus 1, it is. Okay, move the tail back. Tail minus minus as well, right? Ta-da, there it is. Okay, so what's in this case, right? I have this case where they're the same position. I say, okay, tail is 0, it is. That means tail is minus capacity, okay. And I say, head is tail plus 1. It's not. Oh, should I wrap this around? Maybe if I wrap this around, right? Like this. Do I? Oh yeah, I need to do this. In this case, Yeah, well, it's not gonna work either. Because tail +1. Oh, it is correct. Okay, yeah. That means I should move the tail back. But that means that no, this is a special case actually. My God, I've put myself. I still have this special case, except that I'm not writing it into one if. Okay, so that's gonna be horror. You know what? Let's not do this. I'm just gonna do this +1, and I'm gonna say else if. I'm just gonna make this as a special case, and that's it. Now I'm losing my touch with this. What is going on? Where was I? Where was I? I was moving this thing, right? My God, I'm lost. Head is tail +1. Yeah, tail is 0. It's not. Tail minus. Okay. Move the tail back. Okay. Head is tail +1. It is. Good. Move the tail. Good. But if this is the case, right? Tail is 0. It is. Tail capacity. There it is. And head is tail at 8. But else if head is 0 and tail is capacity -1. In this case, oh, sorry, this should be the head. Yeah, the head should move. In this case, put it at the back, right? Then it should be like this. Does it? No, wait. Wait, what in this case? Does it go forward or does it stay? No, it should be here, right? Yeah, because... No, wait. Oh my God, my head hurts. My head hurts. It feels like it should be exactly the same thing as pushing back, but due to the thing that I'm using size t, which is... Maybe I can just use int and just go into the... Yeah. Hello, Manadono. And the folks. Okay, let's reiterate. So what happens in this case when I don't have a thing? The tail is here, the head is here. No, the head should be here. Okay, so I say, look. Look. Tail is 0. It's not. Okay, just move the tail back. Good. I've moved the tail. Okay, so the head is tail +1. It's not. Good. Nothing happens. Head is 0 and tail is capacity -1. Tail is capacity -1. It's not. It's not here, right? So do nothing. That's good. That's actually good. And then at the end, of course, data tail is t. Okay. Else, oh yeah, of course, if I don't move the head, the size will increase. So size ++, right? If I do move the head, together with the tail, that means that the size stays. Oh, jeez, stays the same. Size stays the same. Didn't think this would be hard to pronounce. Okay, so tail is 0. Yeah, but I'm confused about this. I think I'm definitely doing something wrong. Okay, so the when does it not get the same? The problem is when it's completely full, right? And let's say that the both head and the tail are here. So that means that this is the last element, and that last element needs to be overridden. So what I do is, if it's 0, no, it's not, tail minus minus. Okay, move the tail back. Moving the tail back. Good. Okay, so the head. Is the head tail plus 1? It is. Good. Move the head down. Perfect. Okay, and then just replace the data. That's good. Okay. Okay, what happens in this case, right? We've just renamed this to something else. A 6. Okay. So now, logically, if we want to push into the front, we want to change this into a 7, right? And what's going on? Okay, if tail is 0, yes it is. Move the tail. Move the tail to the front. That's good. Okay, now where the tail is pointing into the front. Is head tail plus 1? It's not. Good. Okay, but is it? Is the head at 0? It is. And is the tail at capacity minus 1? It is. Good. Then put the head to capacity. Put the head to capacity. This is incorrect. Yeah, I should actually be here. Because now I turn this into a 7. And the final element is 3 now. So yeah, this should actually be capacity minus 1. And that's it, except that it's so crazy that it's completely different than the pushback. Okay, let's push. Let me actually put this one in here and put this one in here. There we go. Push back. Yeah, pushing back was so simple. Because we just do a modulo. And then we move this. And then it's like, oh, we have moved the size. Yeah. And in pushing on the front, we have the special case. Okay, let's try it. Let's try if we've actually done it correctly. So what I'm going to do, push back. Yeah, let's actually push front. And I'm going to push. Let's do a push like a 99 or something so that we can see it. All right, and then I'm gonna output. So let's see what happens here. Just a simple push front. If it's gonna break. It didn't break. Good. So there it is. The tail. Oh, this is the special case. Exactly the special case that I was thinking about. So yeah, in this case, the tail is here, the head is here, right? That's the one that I was trying to solve here. So the tail is here, the head is here. The tail moves to the front, and the head needs to move back. So there it is. This is the final element. The size didn't change. We've pushed the element. Okay, let's push. You know what? Let's do like yeah, let's go back like in time. Let's push 98. Let's push 97. Let's see if this just works, right? Or not. There it is. Oh, sorry, I'm eating. It does work. They have both moved 98, 97. That's great. That's perfect. That's very nice. Okay, let's continue. Let's see if that's going to wrap around nicely. I'm just going to do dumb programming by copying and pasting. There it is. 97, 96. Bang, wraps around. 95, 94. Beautiful. Beautiful. But here's my problem. When I'm pushing things in constantly, the head actually jumps over here, right? The tail is at 0 and the head is over here. When I'm popping, when I'm pushing to the front, that never happens. How is that possible? Oh, because in this case, the head should actually jump to the end. God, there is another case. If tail is 1, if tail is 0, wait a minute. If tail is 0, tail is 0, head should be capacity. Right? There's 4 cases. Is that because I'm not I'm handling this one too late? Actually, this is confusing because if the head is at 0, the head should never be at 0, actually. I just realized. The head is never at 0 because if it goes over, it goes beyond. And when the head goes beyond, it's at the tail. And then only when it moves the head is that the head becomes the same. Wait a minute. Shouldn't the head always be at 0? That is a bit strange. Maybe the head should move to 0 after this. After this. Yeah, I actually have. I just realized that I have a case. I have the case of equivalence, and that's this thing. So when the buffer is full, right? When the buffer is full, I have this case. Tail is at 0. Head is beyond. 1 beyond, right? But what about this one? What about the head is over at 0? That's the same thing. It's exactly the same thing. So actually, head and tail should never be together at 0. Head and tail should never be. at 0, but they are when I remove stuff, right? When I start removing, there it is. We start removing head, tail. No, wait. Where's the removal? Head starts pushing the tail back. Oh, this is okay. Yeah, in this case, when I'm adding, I keep the head outside. Okay, so the question is, should the head wrap around or not? Okay, which case should never happen? This one or this one? And I'm thinking maybe this one should never happen. Maybe if the head and the tail are at 0, that means it's a complete, you just read from 0 to the end. Or maybe this one. This one should be invalid. Yeah, it is interesting. So here's the thing. The problem is, when the tail is 0, the head should move to capacity. Yeah. But if... yeah, then I should be able to remove this case. If head is 0, because head should never be 0. Head should never be 0. This doesn't make any sense, right? But what happens when I pop back? Right? I say minus minus size, head is minus minus. Yeah, and in this case, if head is 0, oh, we are going to have an issue. We are going to have an issue because this is what happens in the beginning. At the beginning, the state is, I don't have an empty one represented here. But at the very beginning, both are at 0. They're both initialized to 0. So that's the case where the head is actually in 0. Yeah. So in case I pop, this is the thing. What I can do is I can also pop at the beginning. Sorry, I can pop front. I said all the opposite things. I can push to the front at the very beginning. So I can say push front. And then I move the tail. But actually, it should put it here. Because there's nothing. But what I'm going to do is I'm going to wrap around. And since they're at the same position, they should be going back. Yeah, so I have this weird case where the tail goes beyond. Yeah. So here is what I'm actually going to do. I'm actually going to disallow the head being over here. That's much easier. So here is the thing. When I push back, I'm gonna move the head. The head is beyond, right? The head should increase. Oh, this means that I need to redo everything. Yeah, I'm doing the head plus plus. But if head is capacity, I actually want to make it 0. Yeah, what I do here is I flip it around. And then it becomes 0. And then I move it. Okay, let's see what happens in this case. I have a feeling like it's gonna break. Oh, it didn't break. But there it is. H goes beyond, and then it goes... Instead of going beyond, it actually comes back. And this still works. 0, 1, 2, 3. Oh, 0, 1, 2, and then unallocated. 0, 1, 2, 3. 0, 1, 2, 3, 4. 5, 6, 7. This still works. 8. That is actually perfect. 9. And then we go decrement. And then if the head is at 0, here's the problem. The head should be... Yeah, if head is 0, I should just keep it at 0. So pop front, pop back. If head is at 0, keep it at 0. Right? But if head is at 0, yeah, don't... If head is at 0... Yeah, just don't move it. Pop back. But there's a problem because it never wraps around then. I need to check here if head is 0. Wait a minute. Okay, now I have to rethink everything. So if both are at 0, right? Pop back. Yeah, actually this is going to work. Maybe I don't even need this. This is just going to be head. Right? Because with the 0, if head is at 1, I just decrement and I take it. Okay. And if the head is at 0, okay, the tail is at 4, as at 3. Yeah, I need to make sure. Before I decrement, if head is at 0, head is capacity minus 1. Else, I decrement. Yeah. So if it's 0, I wrap it around. Otherwise, I just move it down. Yeah. Okay. Let's do another test. Okay. Okay, I'm gonna pop how many things? No. I'm gonna push 4 things. 4 with an int. push back. Okay, and I'm gonna output every time. Push back I. Okay. Right. H is at 0 again. And that's good. That's good. Okay, let's go. You know what? Let's have some kind of a int, which is gonna be my A. Let's call it A, which is like accumulator or something. And I'm gonna just A++ every time. No, I can just do this. A++. Okay. Okay. There we go. Let's do it 20 times. Let's see what happens now. Okay, that looks good. So head goes ahead 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so let's end up at a 4, which means that we have both the tail and the head are at the beginning, right? But it's not, it's the size is 4. So now I want to pop back after this. I'm gonna pop back, and what should happen is that the head should jump to the end. Pop back. Okay. There it is. It did jump to the end. Okay, and technically it should be able to remove all of them. Right? Yeah, we just do it 4 times. It should remove and get to the empty one. There it is, the size is 0. Okay, so putting in and then going back, tick, 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 tick. Okay, but here's the thing. I can also try to offset it by 1. So instead of pushing, let's start. Yeah, let's start with an offset. So let's see what happens. Yeah, so we have pushed the T here. We move the head 5, 2, 3, 4, 5, and then we pop the 5. There it is. Okay, it's good. So we have handled the most difficult case. Yeah, I think this is it. I think I figured it out. So this is so we should never have the head outside. The head should actually be at 0. So that means that the 4 is here. That's the main problem. That's the main problem we had. Okay, so in this case, when I'm pushing the back, head should not be this capacity, right? Or it should. Yeah, it should actually. But let's me rename it as if head is more than equals to capacity, then head is 0. I don't know, it just feels natural, more natural to me. If head is more than equals capacity. But it will never be. That's the thing. This is never happening. This is never happening. Because it can't be beyond. So I think this goes to the trash. So simply, what we do is we check if the tail is ahead and size is not 0, which means that it's full. Tail plus plus tail. You know what? This is This case is actually just size equals capacity, right? That's the thing. Tail plus plus. Okay, so I move the tail, and I move the tail, and I make sure that the tail is not beyond capacity, right? And that's good. And then I increment the size. I put the data, yeah, and then I increment the head. And I say if head is equals to capacity, then it's 0. Yeah, this is where I'm actually wrapping, so that's why this wrap is not needed anymore. Okay, so what happens when I push front, right? What happens when I push front is that head should never be 0. This is incorrect. Now we do have a 0, but the head can't be capacity. Yeah, so if tail is 0, tail is going to be at the end, right? But I also want to move the head. So yeah, I should now repeat this one from the up. If head is equals size is 0, it's not 0, then I move the head backwards instead, but I need to make sure that if head is 0, head is capacity minus 1. Else head minus minus, right? This is basically the same thing that I'm doing here, right? Tail plus plus, and I say tail. No, I don't increment the tail. What I'm going to do is if... Wait, I'm incrementing the tail, right? Yeah. I basically need to say if tail is capacity minus 1, then tail is... then tail becomes 0, right? Tail becomes 0. Else tail plus plus. So the tail moves. But if it's the final one, then it should pop to the 0. Yeah, so basically, here's the thing. Here's the thing. If we push front, it's the same thing. Yeah, now we have a mirroring. Except that in this is the case where it's 0. We jump to the back and we decrement the... Okay, so what happens then is that the tail should go down, except... Yeah, but first I actually need to get the data. Yeah, I need to decrement. So I'm gonna do... Yeah, well, this is it. Tail is capacity. And then I say data tail is t. And then I have all these things for the head, which is no longer needed. So I can completely destroy this. And I think this is it. Add plus plus. Yeah, I can even rewrite this. I can even say if head is capacity minus 1, head is 0, else increment, like this. So yeah, there we go. We have the same thing. The only difference is that the data gets set afterwards, and then we just return data tail. And yeah, I'm gonna just grab a reference, push front. That should be it, hopefully. And now I can just forever forget this push front. Okay, so let's try this. Let's try a push front. Whoops. Hello, Mr. Cobalt. If you want to know why GLTF was so weird and broken in Flex, we're talking about Flex again. It's because the ASIP library is a pain. I'm trying to fix the integration with it right now. Oh no. Yeah, I use the tiny GLTF. That's what I'm using for my engine, and you know it works pretty well. Maybe Flex should move to tiny GLTF. Okay, let's try to push front. Let's do a 99 as I did. And let's see if this works. Okay. Oh, bad. Bad, bad, bad. Oh no, it's not bad, except that I forgot to increment. Where's the size? Oh, I forgot to add else size plus plus. Here we go. Okay, so it was completely empty at the end, and then I push one more into the back. Okay, let's push more. Push front. Okay, let's put this in a fur. Let's put this in a 4 of, I don't know, 10 times, and push some stuff. And let's do this like 100 minus I. Okay, there it is. So let's see. This is the moment when it gets empty, right? This is now. Wait a minute. No, this is when it fills up, right? It's full, and then it gets emptier and emptier and emptier and emptier, and now it's completely empty in this moment. It's completely empty, and I push front. So I move the pointer back. I put the 100. And then I put a 99. And then I put a 98. And then 7, 6, 5, 4, 3, 2, 1. It's perfect. It works. Okay. All right. So here is what I'm going to do. Final test. So it looks like everything is working. Except for yeah, pushing and yeah, I can now delete this. Okay. So I have the push back, push front. Everything is good. But now I have the pop, right? And I have the pop front. That's the only thing I didn't implement. By the way, I did put this pushing and popping front. Pushing front. Let's put them in different categories, because turns out that this was the this was the most difficult thing to do. Pushing front. Okay. Popping front. So it's basically the same thing, right? We cavity assert, not as empty. Not as empty. We're gonna reduce the size. And we're gonna do like, oh, if tail is capacity -1, then if it is -1, we're gonna move the tail to 0, right? Which exactly mirrors, oh, I put a semicolon, which is exactly what it does, right? But else with tail increase, right? Because we're gonna pop the front. So what does popping front mean? It means that we're like removing the front. Oh, no, we're not bending space. We are removing the front element, right? So we need to increase the tail, except in the case where, of course, it's at the end. So if the tail is at the capacity -1, then we put it to 0, right? And of course, what we need to do is we need to return the data at the tail, but actually before we do all these operations. So in this case, I'm going to keep the index old tail as tail. Okay, and I'm going to return the tail. Return the old tail. There we go. Okay, so that should be it with popping the front and the back. And by the way, is empty and is full, very important thing, this can be const. This can be const. All right. So let's see if that works. If I can just pop front from whenever. Let's do this one. But instead of doing this, I'm gonna say oh, not pushing. Wait, where's my pop? Yeah, there is a pop back. I'm gonna pop back. Yeah, no, I'm gonna pop front. That's what I meant. Boom, there it is. Okay, so what did happen? The tail is here. Increase. Okay, well, actually, this is not the edge case that I want. So let's just add one more here. Just add one more. Let's make that 666. Just so that we can see it. Okay. So here it is. Okay, we have a moment where we're popping the front, right? This is the thing. We stopped here. We are popping the front. Wait a minute. Oh no, this is where I added one more. What the hell? Wait. Am I pushing front? I'm pushing one more to the front. What the hell? Wait. How did they split here? Why did the tail push front? Oh, it's because I didn't check here. Okay, yeah, I forgot to actually debug the intermediate result. What's going on? Come on. Okay. Where does the 666 appear? There it is. Okay, yes. There is a tail, and then the tail moves forward, and then the tail jumps back. That's perfect, yeah. That's it. Okay. So, to finally test everything. Okay. To finally test everything. If everything is working. So it seems like my minimal ring buffer works. That's cool. Okay. But to test the whole thing, this is what I'm gonna do. I'm gonna hide this again. I'm gonna make a little test which uses random values. I think I have some random thing here. Random range. Yes. Random value. Okay, this is what I'm gonna do. Wait, is random range? random range is an int. Okay, so here's what I'm gonna do. I'm gonna do a for, I don't know, 100 times. And I'm gonna randomly pop in and push things, right? This is like a... okay, I'm gonna have an int, Randy, let's call it Randy. And I'm gonna say random range from 0 to 4, right? Is it actually exclusive or inclusive? Random max, I guess it's exclusive, I don't know. And I'm gonna do like, if Randy is 0, I'm gonna push a thing into a buffer. Push back, and I'm gonna do a plus plus. Okay, and then I'm gonna say, oh yeah, and of course I'm going to always, okay, else if Randy is 1, else if Randy is 2, and else if Randy is 3. And I'm not sure if this is inclusive or exclusive. I have no idea, but it doesn't really matter actually, because I'm just going to skip those cases where it is. And I'm going to output, yeah, after every operation, I'm going to output ring buffer. Okay, and you know what? I don't actually need to do this. Oh, I might need to do it, yeah, later. Anyway, buffer. Let's keep these. Buffer push front, right? We're gonna push to the front. And here I'm gonna pop front. But here is what I'm gonna do. I'm gonna say if buffer is empty, right? If not is empty, pop. That as simple as that. And then if not is empty, pop back, right? Pop back from, let's put that one here and this one here. Okay, so it's just gonna be randomly pushing from one side, the other side, okay. And after everything, I'm gonna output. Okay, but I'm also going to say something. I'm gonna say here, I'm gonna say push back, and that's about it. Push back, yeah, and then I'm gonna say push front, and we have pop front, pop back. Okay. So let's see how this goes. If everything is gonna work. Whoa, 100 things happening. Oh, but I actually need to check if is empty. Let's see. Yeah, that should have been inside. You know what? I'm gonna do like else, put it in a big thing, and just put a this one at the front. And yeah, there we go. And then we don't need this, and we have the outputs correct. Cool. Okay, so here we go. What is going on? Oh, except that the messages are actually at the in front, which is a bit annoying. Okay, so first pushback happens. Param, we put a 1, and then we do a pop back. Okay, pop back 1, and then we do a pushback. Okay, 2. Okay, pop front. Nice, it moved forward. And then we do a a push front, right? Oh, there's nothing here. What happened? Maybe this was skipped. Ah, yeah, of course, when we skip, we also debug. Push front. Yeah, to the front, bang, T3. Push front, another one, bang, went all over the other side, 4. Pop front, yes, we go back to 3. Pop front, yes, and then with 0, and then we do a pushback, and it's a 5. And a pop front. Yeah, we retract, and then we do nothing because it's all pops. Push front, yes, push back. How far it's going to go, I wonder. Size 2, size 3. Oh my god, size 3! We got it to push multiple times. Push, 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 push. Push. Wow, 6 pushes, nice. So I did manage to fill up the buffer amazingly. Okay, so we pushed front. We pushed back, right? This is cool because it's like it was empty, and then pushed back, put a 6, and then we pushed front, and I put a 7. And then it pushed back, which means it pushed 8, but the head flipped to the other side. And then we pushed the front, which means that they're the same place, and it's 4. And then we push another one, push back, which means it overrided the old one. And push back. Yeah, and then we do another push back. Nice. For the 11th thing. Nice. And then we pop. We finally pop. Cool. There we go. Okay. So yeah, and then the other stuff happens, and you know it makes sense, right? 38, 40, 42. They're all they're not like crazy stuff didn't happen. Oh, and finally it finished with the size 1, which is interesting. So I think the ring buffer now works. Okay, cool. We have implemented popping front as well. Okay, we should do an indexer as well. And the question is, yeah, should it index the data or not? Okay, by the way, let me do, where is my, not collections, there it is. Okay, let's submit a ring buffer. Chunka. I have some ridiculous things here. Let's remove the chunka. This is something I tried last time. And chunka. And what about a fixed vector? Yeah, I should submit that as well, I guess, because it's already in the... Okay, so the chunka is gone. Yeah, anyway. So here we go. Working ring buffer. Bare bones ring buffer. There we go. Okay, so we have that. So what about iterators? Oh, and one more indexer. Yeah, let's do an indexer. How did I actually do an indexer before? Oh, it's an operator. Yeah. Only bounds checked by entire size, not by a live count. Okay. So we are going to... I don't know what exactly is the policy for the indexer. If it should throw or not. Well, mine is not throwing, it's just asserting. It's asserting dominance. Okay, bounds check. Yeah, basically I need to check. Yeah, so here's the thing. I need to calculate. This is not as simple because I calculate where the index is depending on the... Yeah, so in this case I can use a modulo. And that is actually a foot... Yeah. The only thing I need to check... Well, no, this is not going to work. Operator. Yeah, if I have wrapping, right? If I say I basically what I need to do is it's size t index is I tail plus I modulo capacity, right? Basically. But the thing is that I do need to see if it is more than the size, because it can't, I can't be, yeah, I must be less than the, yeah, that actually makes sense, right? Because it must be less than the size. And that's basically it, right? I can actually replace this. Yeah, let's actually try that. And yeah, we should also have like a const and a non-const, right? I think that's a difference. I think there's a difference between a const reference and a non-const. Can you do this? I guess it's not saying, it's not complaining. So at the end of the whole random thing, let's just have a random pushes and pops from both sides. Okay, at the very end, I'm just going to list all the remaining elements. So I'm just going to say, no, or you know what? I'm just going to push back some stuff. Okay, just to make sure that it's completely full. And I want to say for buffer size, buffer I, std cout buffer I. That's it. And I'm just gonna put in new lines. All right, let's see if this works. Oh, what the hell? Interesting. Who knows what memory we were pointing into? Okay, so it did find the first element, which is like 50. Where did it find a 50? Oh, well, 50 is, yeah, okay. Okay, yeah, I didn't output the last thing. Okay, there's definitely a problem. There's definitely a problem. There we go. So there it is. It's the first element, and then it didn't wrap around at all. Why didn't it wrap around? Right? If it's the tail, did I just shut it down? I did. If it's the tail plus I, oh, I'm stupid. Okay. This is why C++ and C is great, is foot gun, right? Because I was doing a modulo of I, and I just got gibberish, and it doesn't even tell you like you got gibberish. It just does. It just gives you random numbers, but that's why it's fast, because it's not checking every time, every operation. There's no checks. There it is. So 50, 51, 52, 53. Makes sense. Great. It works. Let's try without adding so many things. Yeah, let's just add one more thing. Okay, it only had two things. It was 49, 45. No, it was 48, 50. 4850, yeah, so that's the correct answer. Okay, we have made an indexer. Okay, well, now the most interesting thing about implementing a container, which is a iterator. let's say that I've added a ring buffer, added an indexer for added indexer to ring buffer. Okay. All right. So now what I'm going to do, what is an iterator? Well, the iterators allow you to do a for range for. So instead of doing like an I thing that goes until a size, I can simply do this and I can say, okay, int reference, whatever. Oh yeah, there's actually an R4, and I can just say I buffer, right? But right now, I can't do that. I can't do that. That would be cool. That would be cool to be able to do this, right? Because I don't need to reference anything. Much easier to write. The problem is that, as it says, this range-based for statement requires a suitable begin function, and none was found. It needs a begin iterator. And in case of my other vectors, there it is. I have, for example, this one, fixed vector. It calls a debug, and yeah, if I go to, for example, the swapping pool, you will see at the very end that it has an iterator, and it has a begin and it has an end. And yeah, what you basically do is you get the iterator, which is a pointer to the data, and then it just iterates through the whole thing with these operators, right? And yeah, so that is exactly what I'm going to copy over and into. Yeah, and by the way, yes, these iterators are basically magic, as they're magic because it's not like in C# where you implement an interface, right? You have like, oh, you want something to be like iterable, whatever, you know, it's, oh, I think it's I enumerable is in C# or something. And what you do in C# is you put this like I enumerable, right? And you put like, it's there. And now you implement this interface, right? And it can now use it. That's not the case in C++. In C++, oh, and by the way, in C#, when you implement an interface, right, you say whatever, it will also give you an ability to, you know, to like go into the menu and just implement all the things you need to implement, right? And it will magically do this. Not in C++. In C++, basically how it does this magic thing, which is the range for, the for each, right? How it does it is basically by duck typing. So what it means is that it just looks into like, does it have a begin function? No, it doesn't, right? So if it doesn't have a begin function, it's not, you can't use a range for, right? So there's no interfaces to implement. Instead, it just looks for a function and it says it doesn't exist. You can't use it, right? So you just add the begin function with a certain signature or whatever, and then yeah, for example here, you can just do begin and end into the ring buffer, whatever, and then it's going to complain about something else, right? And then you just add an iterator. Yeah, well, you can have like an int or something, right? Let's do that. And then you go to main and it says, hey, you know, the iterator type is in this range-based for statement is int, which is not a pointer type or an iterator. So basically, like, you look into this and you just look at the messages that it gives you and you just try to implement all the stuff that it's complaining about. Or you go online and you Google and then somebody has put it on the Stack Overflow and then you copy that, which is kind of how I did it, right? So, you know, now it's complaining that it's an int and not a pointer, which makes sense, right? it's not an iterator type, pointer type, or an iterator-like class type. Yeah, it needs to be an iterator-like, but that's the best thing, because like, what is an iterator-like? An iterator-like, it just needs to have certain functions. That's the point of, that's what is basically called duck typing, right? It looks into the class, it looks into a type, and it just looks for the signatures. Like, oh, do you have this function? Does it return this parameter? Does it accept this parameter? That's basically how it works, right? How these magic things in C++ work. And it takes some time to realize this, right? But for a lot of things, when you want to implement classes and structs, you have this magical stuff that you just Google, and then you're like, oh, this is how it works. Okay, so let's just add this iterator. And the thing is that it should already work, except that it doesn't have heady. Instead, I just call it a head. So it shouldn't be able to find it. It's not complaining, which is, yeah, data is the data, but heady doesn't exist, so it's head. Okay, let's see if this works, right? And now it magically works, right? The range-based form. But here's the thing. It's not the same as a swapping pool. A swapping pool is compact. It doesn't wrap around like the ring buffer. Required for range 4. Yes. So basically what I have to do is the end is actually the tail. Yeah, this is going to be a bit complicated to see. Because what if they're at the same place? It's not going to wrap correctly. We can just test this out quickly, but you know, it's not going to be the correct, because it's just going to go from 0 to the end. Didn't do anything actually. No, because the head is probably the beginning, right? So yeah, begin should be data plus head. The end should be data plus tail. Clearly. But yeah, the problem is we create the iterator with the data. Yeah, this is so confusing. I hate when classes are used as functions. Oh, well, this is actually a constructor. I see. Required for range 4. Okay. So yeah, we are advancing the pointer here. But we actually need to wrap it around plus pointer. Yeah, let's unpack this. Let's unpack this slowly. Okay, so we have the operator plus increments the pointer. I would love it if it actually worked with indices and not pointers, but the iterator is the pointer basically. Can I actually move to the non-pointer iterator, I wonder? Yeah, then I need a data. That's the thing. How does it know where the... because it's the end. But I'm not referencing an add anywhere. Yeah, iterators are weird. This is checking equality. This is dereferencing. Dereferencing is just a pointer. But maybe I can turn this into my own arithmetic. Yeah, the iterator doesn't have any data in it. But maybe it could have a package private. Yeah, it does only have the pointer. What if I turn it just into a... Yeah, this is... Yeah, it is strange that this iterator is only operating on the pointer. Like, it's just incrementing the pointer, and then it ends... It ends when it matches the pointer. When it matches the end. Okay, so I'm thinking, what if I just use an index instead? Because we can't rely on the pointer in the case of the iterator. In the case of my ring buffer. Well, I would need to wrap it around, but that's not gonna work. The problem is I need to know the size. Tail. Ah, this is where I'm actually pushing the tail. Okay, so let's rethink this, right? Let's just use an index instead of a pointer. It's a pointer type, but can I actually use an index? Let's just Google it. Iterator with an index. Index versus iterator. Do they work with all containers? Okay, I know how to fix this. Okay, so I have an idea. The idea is to store No, that's not a good idea. I was thinking about storing the end. Storing the end, like... Okay, we like store the pointer to here, right? And then when I'm increasing the iterator, I know that this is the point where I need to wrap around. The problem is that the end can be the same as the beginning. Yeah, I understand how the iterators are self-contained, because you know what? I'm just gonna pass in. I'm just gonna pass in the data pointer. Why doesn't it give me IntelliSense? Okay, what if I instantiate with an int? Okay, there it is. It's giving me issues now. So this is why IntelliSense didn't work. Okay. Oh, t is int. Okay. So I take the data. I am going to still need the begin and size, because I need to pass that into the iterator. I can't just increment the pointer until it matches the end. The end should be the size. What if I do something like this? Can I name it the same? Is it gonna work? Yeah, I'm gonna need. Yeah, I need the size anyway. Yeah, this is what I'm confused about. Okay, I'm gonna take in. I'm going to take in the index. And I'm going to increment the index instead. But the iterator needs to construct itself. This is where... This is what I'm confused about. I mean, I think this could work, but maybe there's too much data. Like the iterator should just be one pointer. It should be very easy. But yeah, in case of a wrapping thing like a buffer, that's not that easy. I do actually need to have the size as well. Or a capacity at least, so that I can... But yeah, I need... yeah, this is... Wait. How does... Okay. So basically, in a normal array, right? In a normal array, you have begin and the end. In a normal array, you have a begin and the end. Here's a normal array. And you can say, okay, this is the beginning, this is the ending. And the iterator is simply just a thing that is a pointer, and it's like, okay, it's the beginning, move the pointer, move the pointer, move the pointer, right? And then it matches the end, and you say, well, that's it, that's the end. Yeah, that's way easier than wrapping the thing around. So if I want to wrap the thing around, like in this case, you know, I have the tail in here. Sorry, the head is over here. The tail is over here. What I need to do is I need to increment the pointer. I need to increment the pointer. And I need to wrap it around. I need to know where it's going to wrap around. And then also I need to handle the case where they're the same index, right? So if I begin and I say, well, they're the same index, that's over. Well, no, it's not over. It's not the end. The end is if we went all the way to the end. Yeah, I have a feeling like I need 5 values to keep track of this, to just, instead of just incrementing a pointer, right? I need a point where it wraps, and I need to know how many indices is going to go back. So I need to know the size. I need to know the size of the iterator. Can I avoid using a constructor? Oh yeah, well, this is because it's a private. Let's put the data on top. I hate it when the data is on the bottom. Okay. Yeah, I need to know where the end is. The index yeah. And then I have the capacity. Okay, let's have it like this, right? Capacity. All right. What's wrong? Capacity. Okay, it's the same thing. All right, so when I I increment the index, but what I return is the operator there. That's the same thing. Okay. Equals is data is other data, and index is other index, right? Not equals is data is not other data, and index is not other index. Okay, so how do I dereference? Well, dereference is going to be data plus index, which is not correct. Yeah, I need to know wrap point. Maybe I can pass it a wrapping point and then just wrap around minus capacity. So that I can increment but yeah, I do need to keep track of the index, because how am I going to know that it's the same thing? Okay, let's see if this works. First, you know what? I'm gonna keep this as a pointer. I'm gonna keep this as a pointer. Index. Yeah, and instead of capacity, I'm actually going to have a wrap point. So there's not going to be index. There's going to be wrap. Oh, sorry. No, index. Capacity. Wrap point. Okay, so the data, yeah, the operator is just going to be pointer, right? The old way. And the reference also going to be the const pointer. That's good. But the increment, now this is the thing. How do I increment? Basically, what I'm gonna do is I'm gonna increment the pointer. I'm going to increment the pointer. I'm going to increment the index. But also, I need to check if pointer equals wrap point. I need to wrap it around. Oh, well, yeah, I do need the size of the whole thing as well. It's going to be pointer minus capacity. So I need to keep all this data inside an iterator to be able to do anything. And the reason why I have index is so that it doesn't overflow. So that, you know, if there is the same pointer, yeah, they need to be like different things. Yeah, I need to have a capacity. Oh my god. Okay. Yeah. C++ is so annoying to write. You have to copy so many things. Capacity. Yeah, this is why I don't like constructors and destructors. Because at the end of the day, it's just copying stuff. Okay. Capacity. Okay. So yeah, I need to wrap it around by capacity. So, and I increment index as well. And then it returns the, okay, well, I can do both. Okay, so the way I create this, yeah. So this is going to be pointer is not pointer and index. So I need to check both the pointer and the data. Okay, so here's the thing. If it encounters, yeah, I need to get the wrap point, right? So iterator, it's gonna be, first is pointer. Pointer is data plus head. Wrap point is data plus capacity. And then we have the index, which in this case is 0, and capacity is capacity. Maybe I can calculate this from data. Okay, so, and the end is going to be data plus tail, data plus capacity. Index is capacity. Wait, no, index is actually the size. And capacity is capacity. Right? Because this is the head. This is the ending. Okay, I wonder if this is going to work at all. Okay, let's do a little test of just the for loops. There it is. Okay. So this for loop, this ranged for should return nothing. Ring buffer. Okay, yeah. It did kind of return nothing, right? Okay, so if I push something into the buffer, push back a++, right? It should get me a 0. That's good. Yeah, okay, so far so good. Oh my god, it doesn't work. Why did it output 2 zeros? Detected, IntelliSys detected a problem. Great. Maybe I need to restart Visual Studio. Sorry about this. So 4.5 hours of streaming. I thought this was going to be much shorter. Okay. So what is going on here? Why is it not working? Let's see. Okay, this should be not 0, it should be 1. Okay, this should be equivalent. Would it be a violation if I just pushed an iterator? If I just pushed the pointer to the ring buffer? To the iterator? And I just did index. Oops. I have a hiccup. Normal 4. Range 4. Okay. So these two should be equivalent, you know? 1, 2, 0, 0. So why are they 0, 0? I increment a pointer, I increment index. If the wrap point, I decrement by capacity. And return the self, which is this. Data plus capacity. Begin. Wait, why is this 0 here? Oh, this is the index. The index is first. And the ending, shouldn't the ending be size -1? No, I think it happens afterwards. I mean, the number of elements is correct, right? It's 0, 0. But for some reason... Oh, now it's only one element. Okay, let's also just output the buffer. It should be 1, 2, 3. It's simple. What? 0, 0, 0? Oh, right, because I didn't. Should be here. Okay, 1, 2, 3. 1, 2, 3, and range 4 for some reason it's completely bad. Tail. Ah, fuck. Fuck. Wrap point never changes. Wrap point can be const. Capacity can be const. But it should end with the same index. Oh yeah, then it's not the same. Oh, okay. It's not the pointer. It should be the index. There it is. Almost. Okay. For some reason it starts from 0. Tail starts from 0, but it's actually here. Did it start from a head? Wait a minute. This should be a tail. Oh god. The beginning is... The beginning is the tail, not the head. There it is. Range 4. Normal for range 4. Okay. Good. Okay, so that works. So what happens if I start adding more? 4. works. Okay, 5. Now we have a wrap point. 2, 3, 4, 5. Yeah, it works. Hey, it works. Four, 5, 6, 7. 4, 5, 6, 7. Cool. Okay, it works. And also it does have 4, 5, 6, 7. Yeah. 4, 5, 6, 7. Okay, there we go. We made an iterator, although the iterator is quite heavy because we need to keep the index and we have the wrap points and everything. Okay. Interesting. Okay, you know what? There we go. We did an iterator for range 4. That's nice. Let me quickly just... What the hell happened here? Okay, let's make another buffer. Ring buffer of ints. Buffer. Alloc on heap. And let's try something really big. 64. No, 32. I don't know. I do need to have the same... You know what? I don't need to make a big one. Yeah, I can just increase it here. I can just say 64. Nice. It's a big buffer. It's a range 4, normal 4. Looks fine. Looks fine. Okay, let's try pushing back. You know what? Yeah, let me just save this as like added an iterator. Ring buffer. Added. Okay. Let's do something bigger. And then I can do these random pushes and pops. Let's try that. Yeah, there's so much data now. But yeah, the heads and tails are moving all the time, which is funny. Yeah, heads and tails. Oh, there's the head, there's the tail. And it's completely so far away. That's actually impressive. And then you have the normal 4, 48, 48, 57. Nice. Okay, it seems to work. It seems to work. Okay, let's push like really a lot of stuff. Instead of these range 4s. Yeah, let's do a 4,000. Okay, and I'm gonna do buffer push back a plus plus, right? And then I'm gonna output the ring buffer, and then we do the 2 4s, right? Why did I even? That's kind of funny. I don't need to put it separately. All right. There it is. A lot of stuff. Yeah, the thing is that now the buffer is like It goes to the end and it starts wrapping around. 91,000. Yeah. Well, we can see that the final numbers. Wait a minute. Why is there no thousands? Oh no, there is. Right. That's the last one. It is correct. Good. I think this is good. I think it's a proof that everything works. Hopefully. And that's cool. I can use ring buffers now. I could just push and pop and looks nice. Okay. Yeah. What else did I want to do? Allocate heap. Yeah, of course. I wanted to test. Oh, right. Destructors and constructors. That's one thing that was problematic. Constructors and destructors. Yeah, so what if... Okay, let's kill this one. Let's just kill this one. Oh, I do want to keep the output. Oh, I don't want to keep the output. I'm actually going to hide the whole thing. Let's just do if false. If false. Something like that. Is that even going to work? And if... Okay. Okay, let's do a new ring buffer. Ring buffer of... And now I'm going to use one of those cool ones. Which is my test struct. Right. I'm going to make a test struct-based ring buffer. Buffer alloc heap, and I'm just gonna say buffer push back and empty. Can I do that? Oh, alloc heap. I need its size, of course. And let's see. Yeah, I'm gonna take a struct, and I'm gonna change a. Let's see if this is even gonna work. And I'm gonna say a debug. Okay. Because now it has not constructed itself. Oh, it did. Created, destroyed. Interestingly, that it destroyed. Oh, there is a destroying. Destroying happens inside pushback. Probably it gets used up. Hello, do you use any unit testing framework? No. No, this is just like a main, and then I just do that, and then I just output everything. I looked into testing, but it's so everything is so complicated. I just want to go back to Zig. Programming in Zig, where tests are like integrated into the language, and it's so good. Oh. Okay. Anyway, do you use any testing frameworks? Yeah, so this actually works because I'm passing in and pushing back a thing that gets copied, I guess, here. But it probably gets destroyed as well. So at the end of the day, you know what? You know what did I forget? I forgot to deallocate this. I forgot to free the memory. Great. Now we have a memory leak. So here is, well, here's the thing. I can have a separate data. But this is a trick that I can use. Data to free. So this exists in the case that we've done a heap allocation, right? We do have one extra pointer. Maybe I can just have a bool, you know, but I don't know. I'll just, when you align this, it's gonna be big anyway. Free or not? Should free. Yeah, something like this. Should free is false. Should free is true, right? Oh! Jesus. Sorry. I knocked down my microphone again. Because it's sitting so close to the edge of my table, so when I like pull the keyboard or something, it's gonna. Anyway, sorry about that. I digged into this rabbit hole and I ended up just using printf because it's a mess. Yeah. I think just having a print, because like what I love about Zig is just like that's exactly how at the end of the day tests work in Zig. Just it's almost like having multiple main functions, and then you define tests in these separate main functions where you set up everything, and then which only run when you run test commands, you know. So that's cool. Anyway, void alloc heap. What was I doing? Oh yes, I want to destroy ring buffer. Okay. Sorry, that's a method. When you destroy, I do want to free. Is there a calloc free? No, I think it's just a free. Free the data. But only if should free, right? If should free. Okay, we had no problems, so it did probably free. Ring buffer. Okay, so here's the thing. The question is, should it also destroy these objects? I think it should. I think it should. Because I was just... Yeah. Because this can be anything. So actually, I should go through the whole thing. Oh, not for each. R4. Can I just go through the whole thing? Let's do a... How did I do destructing on my own? Walking pool. There it is. Okay. 4 size, and then I basically destroyed everything. But it should go through the indexer. Yeah, data. No, not the. Can I actually do a this? How do I call the indexer on the self? Call the self indexer. How can you do that? Do I, can I actually dereference this? What's the problem here? Invalid destructor for int. So it cannot destroy an int. Maybe I should just say, you know what? If you want to destroy it yourself. Easy. Easy to solve. Yeah. Okay. Let's skip that. Let's skip that. The thing is that I am intending to use the ring buffer for like plain, how do you say it, plain old data, pod structs anyway. So maybe I'm going too far with this destruction thing. But here's the thing. I can just add a thing to say like handle destruction of items yourself. Something like that. But it does free the data. Okay, anyway, ring buffer. Okay, so here's the thing. Allocate on the heap. Yeah, I definitely want to do the set buffer, which is which you can avoid before using. Yeah, it needs to say before using, you need to either alloc heap or set buffer. And as I was saying, I can put the capacity to be a const. So if I do have this as a const, and then add in a constructor, ring buffer that will take the capacity. I'm not gonna init it. Right? Like this. Then I don't need to pass in this, since I know that I'm gonna allocate on the heap. Yeah, could be like this. All right. So yeah, I am going to have to init the size now. I can init with 32 and then not do this. All right. And let's try making a ring buffer of test structs, which actually uses a local buffer. So if I just create an array buff, let's do a buff, and I say set buffer, it's just gonna be buff. as we did above. Aha. The thing is that it creates all the objects. So if you have an array, it runs the constructor for all of them. Which is not the case in C, right? In C, it will not construct them. So maybe what I can do is, can I just create a... No, I can't, but I can do a char array, size of test struct. But maybe I need to have an align as well. I'm not sure. Probably need to align as well. This is gonna fail so crazily. Static cast test struct pointer. Can I do this? Can I? No. What about pointer cast? No. What is the name of it? Dynamic cast. No, it should be reinterpret cast. No. One of those. Yes. Okay. Let's see. Ah, surprisingly it worked. Okay. Let's actually output all of them. Well, actually there is refer, which is gonna be the stir. Let's just do a buffer, and we're gonna debug. Okay, let's add another one. Oh, it's, yeah, I don't need a reference actually. There it is. It does actually show both of them. Cool. So it has only constructed twice if we do it in this way. That's nice. That's nice. Now the question is if this is correctly aligned for all the objects. I have no idea. But it does work, which is cool. I can set the buffer. It is pretty cool. Okay, cool. I think that I've finished my ring buffer. Which means that I can push it to production. Yeah, to production. I mean, I can just start using it in my game. Hopefully. Is malloc h, like, does it also include calloc? It does. Oh no, it doesn't. What is calloc part of? Core CRT. This is some Windows stuff. Windows. Okay, so maybe I don't even need this malloc because it's gonna be used by others anyway. Yeah. So if I set the buffer, then it shouldn't free. Unused variable. Oh, unused variable. Wait a minute. Good catch. Thank you, compiler. I didn't use the S, I used the A. Okay, still works. Still works. Good. It's a 1. That's good. Okay, let's push a few buffers then. And let's see if it still works. Okay, there they are. They've been created, destroyed, created, destroyed, created, destroyed, created, destroyed. Which is good. Okay, let's see if everything works in release as well. I wonder if these copulations are going to happen or not. They don't. They don't actually happen. So I do actually have a construction here happening in the pushback. And then it gets added to the data. Yeah. Well, that's okay. Yeah, what can we do? What can we do? I mean, I can avoid that, but I could avoid that, but it's a big code gymnastics then if I do. Yeah, so the thing is that the destruction doesn't happen here, which does happen for a vector, right? Okay, let's compare it to a vector. Stud vector of test structs. And push back. I'm just gonna push back an empty one as I did. Let's do 4 of them. And yeah, I'm actually going to reserve some space. No, wait. This is not reserving. Vec reserve. You need to say explicitly. Vec dot. Come on. Reserve. Vec dot. Or for s in vec as debug. Okay. So let's see. Oh, reserve 12. Let's see. Yeah, as you can see, wait a minute. Let me just do a little separator. Okay. Ring buffer ctor dtor. And then compared to vector. So yes, as we can see in the ring buffer, create, destroy, create, destroy, create, destroy, create, destroy. And then when we output, nothing happens. There's no destruction here. But in a vector, we create, destroy, create, destroy. Oh, so pushback still creates and destroys, even with the release version. Create, destroy, create, destroy. And then we do a output, and then they get destroyed at the end. So if we really want to destroy these things, we would need to have to do it manually, like s dot test struct, like this. Yeah, there it is. Now it acts in the same way. But yeah, here's the thing. If I used in placeback instead with nothing, then I would only have constructions and not destructions. There it is. So this is like super optimized with in placeback. But making your own in placeback is so annoying. I could have an empty in placeback or something like that. It just allocates the space without actually, So I thought that this wouldn't make a copy if it's a const t, but apparently it still makes a copy. Which is interesting. Anyway, I think I'm running out of energy. I've done a lot of things today. And yeah, basically you need to handle your own destruction of elements. That's what I'm just gonna say for simplicity. It would be great to be able to somehow check in a const expr or something if an item is destructible, you know, then I can loop through it. Maybe there is such a thing, but I'm not aware of it because it doesn't work for ints, for example. I could add it as a template parameter, you know. Let's see, C++ if destructible. Is there a practical way to check if something STD destructible? The concept destructible is trivially destructible. Okay, there is a concept. That's a 2023. That's a 2023 C++ feature. STD is destructible. No, maybe this is 2020. Is destructible template is present in the type traits. Yeah, I could do this, but then you have to include the type traits and stuff like that. I don't know. I like that I don't have to include everything. Is destructible. Yeah, I can probably check that. Is destructible and then do a destruction. Then I can do, yeah, something like if const expr, no, is it if const expr if? Okay, std is destructible t, right? Yeah, something like this. And then I can do a for and do a t. What is it? How did I do this? Now I forgot. No, I did the normal for loop. Size, yeah, I'm just gonna do a size data I. No, it's not gonna be data I, it's gonna be this I dot t would this work? Detected invalid destructor name for int. So it doesn't care about is destructible. Where's my other vector? Swapping pool. Yeah, it is true. Data head I. I don't know why it doesn't let me do this. Okay. No member test struct in ring buffer test struct. Oh, this is what I need to do. Why? What's up with the colors? They're completely fucked up. All right, there it is. So yeah, I could do this, except that means that I need to include a bunch of things. I guess type traits are already included, or whatever. I can also just do this. So I guess handle destruction is now handled. Yeah, I don't need to do this now. I don't need to call the destructor twice. Here we go. We have destroyed them. That's nice. Yeah, it would be nice to actually construct without a constructor. Yeah, but I'm not gonna do that. Okay. Yeah, they're just passing a thing into a pushback is way easier. You know, yeah, maybe. You know what? Maybe instead of doing this, I could do a auto temp is, and I can just create a new. Oh, yeah, of course, test struct. Let's just do a test struct like this, and then I can just pass a temp because it's a const. I wonder if this is going to do, if this is going to be a copy elision or not. Oh, interesting. Interesting it is. So this is how you can elid the copies. You can just create one temporary and then push all of them with the same thing. So you just create it and then it destroys itself. Interesting. Okay. I thought that this would do some kind of copulation because it's like an empty one, but apparently not. Apparently this is a better one. Okay. Anyway, that's about it. The ring buffer actually works. The ring buffer works, which is cool. Yeah, now it's time to use them in game. I do want to use the. I do want to use it for a. Yeah, let me actually push it. Ring buffer. No, wait. So ring buffer, what did I do? Allocation. Yeah, constructing and destructing ring buffer. Okay. Yeah, and I should probably move these into like getters and not just size and capacity. I mean, capacity is the only thing that I can get without a function, but everything else is pretty much not a. Yeah. Nah, you know what? Maybe making this inline or something would elite the copies. But yeah, it's a micro optimization at the end of the day. Yeah, good thing that I got this iterator to work. That was that was the weirdest thing. Okay, yeah, there we go. We have a working ring buffer. I can rerun my tests, which I had with a random. Yeah, I just made it if false. Yeah, this is the random pushes and pops. Random pushes and pops. And this is, what is this? This is just pushbacks, 1,000 pushbacks. Yeah, this is no longer alloc heap, but I do actually allocate. Okay, buffer alloc heap. Yeah, we can move it there, and well, the buffer needs size now. So yeah, let's do a 32. I think that fits more into a random pushes and pops from both sides. Yeah, let's try this. Okay, run the last test. Now if it fails. Okay, it didn't fail. Good. Okay, so there we go. We have some pushes, we have some pops. Empty at the beginning. Oh, there's a pushback. There's a push front, pop front, push front. Yeah, and then it starts moving. Because yeah, that's the funny thing about the ring buffer, because it starts moving across when you're adding and removing. Yeah, here we have a long buffer now. It's a tail and a head. And does it even go to the end ever? No, this is just it goes up and down. Oh, there it is. Yeah, it leaks. It goes to the other end now. Because it's like, oh, the tail is on the other side. And let's see what's going on here. Oh yeah, well, at the end I pushed so many of them. And finally I have a 4 and a range. Okay, let's actually remove these thousands of pushes. I don't need this one because I don't use it anymore. Okay. So yeah, this is a totally random. Totally random. Yeah, it's so funny that when you do a random walk, they're around the 0. Like they're about here and then they go to the other side, but they never come back, right? They still keep being here. It's funny. Yeah, and there it is. At the end, there's only 4 of them. Normal 4, and it goes from here. So what should it be? Tail, from the tail to the head. It should start with 48, 48, 46, and then go to the other side. 38, 50, and that's it, because this is not. So it should end with 50. Only 4 numbers. 48, 46, 38, 50. 48, 46, 38, 50. 48, 46, 38, 50. Perfect. Validated. Nice. There we go. It works. The ring buffer works. I can now use it for something interesting. I don't have a good use for it yet, but that's only implementing it. Cool. So thank you for joining. That's about it. I showed you what the new Shakedown loader by Stefan. Nice to see that. That's pretty cool. And implementing, and then implemented the ring buffer. I said I should add handle constructors and destructors. Yeah. So there we go. We got it. What's going to be the next stream and when? I don't know. Maybe tomorrow, maybe I don't know. But I'm definitely continuing to work on the game, on the Shakedown rally. So yeah. I'm not going to go on implementing a ring buffer, not like using a ring buffer immediately. This was more or less just practicing, a new, getting into the mood for C++. Yeah, and stuff like that. So yeah, there we go. Thanks for watching. Once again, I can go on and try to play a little bit of more Shakedown and then go. Okay. Is destructible. Thank you. What was the one that I used? Tetro. Yeah, I can just go with the gravel on the Monty. Oh, by the way, a Sweden map is broken. Do you remember Sweden? It never got published, but yeah, for some reason the colors are funky. I realized yesterday that it was broken. This is the sign. The funky colors is actually the sign that the vertex colors are flipped. So what should be the second layer of vertex colors is the first layer, and vice versa, right? The first has become the second. So yeah, it is a little bit of a problem. So instead of this, the green and the red dots, those should be actually the how do I call it? Those should be the terrain surfaces. Yeah, the blended surfaces that define the grip and stuff, but actually they're being used for light map. So yeah, that's the problem. But it still works. It's just a little bit hard to see. Okay, and but yeah, the Finland is still the best. My favorite so far. This is the year. 2024 is the year when I'm gonna publish Sweden and Guanajuato. Okay. Yeah. Anyway. See you next time. I almost died. Yeah, see you next time. Goodbye.